hope it is. Let me see. Yeah, it is. It is correct now. All right, let me do some PR. Before then, let me make this lively. Add some graphics, showing some graphics. Yeah, so about that. I made that there. Then while I'm messing around with things, let me do a drop the beat. 1 minute trying to play an audio file. I'll increase the volume. Let me make some PR and get started. I'll share the link to the broadcast. So put on to the air 1 minute. That was that post us photos profile. I think. Okay, we had 5 people show interest. Abdullah Salim Ali Salim Buffalo yeah, and I think that's it. So let me make a post 6. So I got a link to this broadcast. It's already. So it's already. Wait a minute, sorry. I'm trying to clean this thing up before we get started. Yesterday, okay. Repost this and I'll close. Yeah, please do just retweet the post, the stream, and then get as many people as are interested to the room. Post this. Yeah, I'll do it. Let me know if my internet is breaking. I feel like it's breaking. Excuse me. First about minutes. General is Hrs of Solana. Alright, I think we can start now. We can, we should, we would. Yes, so let me attend to people that are in the room that want to get in. If you tried getting in previously, please send a. Abla is here. Let me bring him up. Is he here? I think he left. Okay, it's not in the chat. It's not backstage, it's in the chat. Cool. So let's do. Yeah, so everything looks good so far, and we are excuse me, and we are good to go. So let's do bring up one. What we'll be doing today is mostly what we're doing today is mostly going over what we started those 2 days ago or 2 days ago or something. I think yes. No, that was Monday. I was going to do a follow-up live stream, right? Let me just walk us through what's happened. I think it's fine. Let me walk us through on Monday. Do I even have a link to it? I think I should. It's this is so let me switch to my background. Switch on program. 1 minute, sir. Was the trees? Yes, this one. Yeah. So this was the Q one we're doing, and this is the anchor one that was done since September. Let me walk us through what's going on there. Did I link? I know I didn't link. Okay, so what is going on here is pretty much so it's very much an anchor. Let me turn off the music. I got carried away by the music. About I read the volume of the music. Yeah, let me just do the volume of the music. Yeah. So what's going on here is pretty much a program which is like an escrow. Everything's an escrow actually. Which is like an escrow, and what we did is majorly 1, 2, 3, 4, 5, 6 instructions. So the admin initializes the state of the program. Then we create a streamer. So it's for a live streaming platform. So we create a streamer. The streamer is basically an account for a new user on the platform, like a PDA for a new user on the platform. Then you can tip user to that account. You can withdraw as a user, and then you can withdraw the fees on the account, and you can withdraw all the fees that have been collected so far on the account. Yeah, that's basically what this program is. So just let me go into the instruction. So we split it out into instruction out on the state side to get an angle of what's going on. So there is this global state, which is basically just the config of the whole platform. So who the admin is, what's the fee of the admin, what's the platform fee account, supported token means what token they support on the platform, the bump, and it's initialized, which is redundant and useless, but yeah, just keep it anyways. So that's for the global config. Then we also have this streamer, which is a user instance. So it says the user pub key, the user token account, and the bump of this streamer. Yeah, that's that's basically what it is. Right? That's basically what it is. So yes, so we want to do want to create. So we tried replicating this. So we have cell state. Let's get into. Let me walk you through the instruction. Right. So the basic instruction. First one was config. Right. Initialize the whole state of it. As the global states. So it's basically it says an anchor project program, and this is just the anchor the account structure, right? So initialize global state. Yeah, applies. Let me add into the stream. Add to stream. Yeah, blah. Welcome. Welcome. See. Can you hear me? Your mic is off if you're speaking. All right. Before it comes on, let me continue what I was explaining. So this is an account state for the global state, which is basically a PDA which is taking this global conf, and we're creating the account basically with the init constraints. And we're telling who the payer is for the account is, and the seed of the account. Then we're also telling Anchor to find the bomb for me. I don't know what it is, because nobody does. Then we are setting the treasury account, the token account for the token mint. Yeah, and we're specifying that the decimal must be 6, else throw this with error invalid mint of checks here with your constraints, with your anchor your account constraints. That's one beautiful thing about anchor that we do not have in Pinocchio. Yeah, I think I have a chat message from Dan that should be behind. 1 minute, sorry. uh, yes, let me get started. Can you see much? Yes, I see much. Right. So it means the system program, because we're creating an account, we're creating several accounts, then there's a token program. We're live already. Live already. 1 minute. I want Dan to come speak about something also, so I'm trying to pull him in. So I started talking program also for checking in on Abdullah yesterday. I had to stream again. Why is it leaving stream? So we have talking program also for doing what I use talking program for. Yeah. I did not actually use talking program for anything. Yeah, I always associated talking program. But I think I needed talking program because according to token account size. Yes. So what we just did in under initialize was this. We check that this this program has not been initialized previously. Then we just pour in everything that we were working with here, right? So self the global state that set inner, then put in what type of state we want to set, and we pour in all of the accounts, not even accounts, all of the structs details, the admin, the pub key, platform fees, E16, token accounts, pub key, supported means pub key, bump, U8, initialize, true, boolean. So yeah, so that's basically what happens in the initialized global state. And we also have this instruction 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 arguments parameter that will pass to this instruction here. You check the source, then we check the source and we check the librs. You'll see here we have this param, which is of initialized param that I just shared. Which initialized param is basically just an AU16 struct, and the only thing inside that struct is AU16. I'm passing it here. This is the under initialized instruction. So yep, that's basically it. Let me check one more time. Under initialized instructions. Under initialized instruction. Which one is? I think it is create global states. Yeah. So the undo initialize instruction here, I'm expecting a params which is just the struct which is serializable and deserializable as an anchor objects, anchor accounts, anchor object, whatever. Yeah, so that's basically what happened in the initialized global state, and we were replicating it here with Pinocchio. Let me see if I can pull that one up. So this for the first part of the program, we'll just be doing okay. The link to this GitHub repository switch from program. The link to the repository is a minute. It's this one. It's the anchor version, is the anchor variant. Switch from is a fuck off. Yeah. Let's copy the link to this. You can fork it, can play around with it so as long as it lasts. Where is it at? Oh yeah, in the chat. I think I cannot make a direct chat. Um, this is it. Yeah. So let me show this. So this is the link to the repository. I can you copy that? I can only make direct posts to YouTube and not on Twitter. So someone can just help me copy this and put it up on Twitter there, right? Yeah. So this is what we are porting. This is the anchor project that we are porting to Pinocchio. And so let me give an overview of what Pinocchio is. For people that don't know what Pinocchio is, do I know what Pinocchio is? Do I? I don't know. CHIO. Pinocchio is a cartoon character, a fictional cartoon character. Right? That's the thing. Pinocchio, and that's what you see, right? But let me search Pinocchio Solana. Yeah, then you go. You have a link to. Okay, yeah, this is. It says Pinocchio is a zero dependency Rust library designed to create efficient Solana programs. Let me create it so you can read off of it. So the idea of Pinocchio is to be a very a lightweight package that helps you think of right Solana programs a different way in a zero copy approach. So you don't want to do a lot of this heavy lifting. Yeah, you don't want to do a lot of heavy things in your program. You don't want to do things that will consume too much CUs or consume unnecessary CUs. If something could be avoided, Like it should have, let's say, it should have massive impact on your program. If you can avoid it and reduce those CUs, you want to reduce the CUs. But if it's something like if you do an instruction that will remove, let's say, two CUs, it's not really worth it. Just keep it down correct. Keep what we're doing before. But if you'd have something of this is a large amount of reduction. So 88 to 95% of so you're reducing your binary size by 40%. Okay, so it reduces the size of the program by at least 40%. Depends on how far you can still squeeze out those CUs, right? So that's what Pinocchio is all about. It makes you write tunnel programs that are lightweight. So you'll be spending 2.5 so deploying the program. This program was deployed on Minute. Last time I think I made a tweet about it was it 2.3 Sol or 2.5? Let me look for that tweet. 1 minute. Exactcom. Let me find it. Tweet. 1 minute. It's a long. That was last week. Yes, it was last week. Yes, this tweet. This is the tweet. This is the tweet. So what I said was I deployed an Anchor program to mainnet and it cost 2.3 Sol. Yeah, it was 2.3 Sol. So I was tempted to rewrite the same program in Pinocchio and benchmark the difference. So let's hope we have all the time today we do to write this to test it, put it on DevNet, see it, then hopefully put on mainnet. Who knows? So with transaction is the transaction hash. I deployed it here. There we go. I picking forever to load up just the Explorer. Shitty internet. Yeah, so this was the instruction. I took 2.3 Sol for creating the account and 0.001 so as a deposit for the program whatever I did. So it created an account and it deployed. So this was creating the account. This was to um, writing the SO file. So the SO file of your program. It has to stay in an account also. So you are creating another account, this account, and that is where the program SO file is written to. If I come to this account now, the account I created was this SWAH. That's the name of it. That's the program ID. But writing that's one that's upgradable. But where your program data lives is this one that is created now. When I come here, you see blah. So let me just prove that this is actually where the program data lives, right? Control T, bring up my terminal. This is crazy. So I'll do Solana account. Then this is the address. Then I want to do I have in URL mainnet beta. Yeah, this account from mainnet and show us yes. So you see, this is the code. This is a very long code, and you can see some of. Let me see if I can make sense of some of these details here. 1 minute. There should be some of the detail that will make some sense. Yes. Number not in range. Start. This is an error. This is an error. This is where this error is living on the program. So it just shows you that this is so it's also blah 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 blah. Some errors. These one are errors. Most of all these ones are errors. The errors are defined in the program, right? So yeah. So that just shows that this is where the program was written to. So your code, your account instruction has to live in on chain also. So that was also created, and that was what took this 2.3. So because it took, and how do you calculate that? I think it's 0. Let me just show you size of data costs, data cost. on Solana per byte. Yeah. So current rent cost is calculated as 6,000 9,960 lampots. That's 0.81234. That's 0.000696 sol per byte. And we created a program that was 2.3. So you divide that and you know, yeah, the program was three. That's how the calculate is three is 1,342 KB. That so that was the size of the program. Yes, 340 KB. So that's 342,000 bytes. That's 342 kilobytes, 0.65. So that's the size of this thing that we created, and it's cost this amount to deploy. So blah blah blah. Yeah, yeah. So that's basically how account cost is calculated onto, right? So let's get back to Pinocchio. So when you use Pinocchio, you can reduce the size of your account, your program, SO file, binary file, because you don't. First thing, you don't have the overhead. The first thing that reduces the size is your entering a lazy program entry point macro. So that one is a lightweight view type, so you can reduce it. So it's a light input parser, then new types with minimize cloning. So it basically minimizes the amount of cloning, every rewriting, copying that's going on in your program. So that's and it's no STD, it's a no STD environment. It means you're not using all of this standard library credits, anything credits, you are throwing that out of the window. You cannot use this. So I was trying to say what I trying to explain again. How Pinocchio optimizes your code. You don't have all of those heavy. You're not using Bosch. Okay, that's inside when the program starts. So you're not using all those heavy copy libraries that would be inside your program that would increase the program size. So you are using something more lighter, right? You're using something more lighter and more efficient. That's what that there are a lot of places that be paramount to reducing the amount of CUs, the size, the program size of your program instruction. And after that, when you are interacting with the program also, you have lesser compute units, you're consuming lesser compute unit because you're not doing all of those copy that Bosch does. I think Fibo Fibo did Fibo sent in a benchmark. Fibo benchmark. Let me see. Fibo did a benchmark about where's Fibo? Let me just look for Fibo. Fibo. My follower. Yeah, I'm following Fibo. Sorry, Fibo. Yeah, this is Fibo. Made it. So this is okay. Yeah, this is what I was looking for. So it did a benchmark showing how these different libraries, yeah, when you use these different libraries inside your program, what's the amount of CUs. So it was just a regular token account, almost like a token account, just loading a token account into the program. When you use Beam code, you're using 356 CUs to load that. When you use Bosch, you're using 617 CUs, and Bosch is what Anchor uses currently. You see, you immediately see why your programs are expensive on Anchor, right? When you use ByteMock, it's 40. I use ByteMock a lot in Pinocchio. When you use ByteMock for that same account declaration, you're using just 40 CUs. When you use Transmute, 6 CUs. When you use Win code, 62 CUs. When you use zero copy, 40 CUs. So zero copy is similar to the same amount of CUs that is for that ByteMock on that same instruction, loading that instruction. in that data account, not even an instruction, just loading a data account. Let me show you what it did inside. So win code is a drop-in, more like a drop-in replacement for bin code. Both of them are copy. It's not zero copy, but win code does it more efficiently. See, from 356 CUs to 62 CUs, and both of them are they're not zero copy. So if you don't want to use, if you don't want to use Anchor, if you don't want to use Bytemorg and Pinocchio, go deep into the stuff, and just switch out bin code or Bosch or win code, and you immediately get a large reduction in C optimization. Right? Let me look at let me look at the repository now. Okay, let's see. Let's get deep into it. Let me share the link to this post also. Copy. Yeah, sure. I don't know. This just feels. I need to be able to send this in chat in real time. Hmm, let me see. Let me see. 1 minute. I just send it in chat in real time so you guys can see it instead of me assuming that I can read it off of the screen, right? So in the chat here, I want to paste. It's loading. Yeah, I just sent it in the chat. So you can, if you check the Twitter chat now, you should see. Let me also send the GitHub repository for people that want to, if you've not seen that. So let me send the repository in chat. Yeah. Good. Yep. So let me show. Yeah. Yeah, you're in chat now. So you can click on it and check it out yourself. So this is the repository. It's called Tide. So it said Tide is benchmarking simulation credits for Solana programs. What I did in the program is, so if you open programs here, you see different folders of what you're trying to do. So if you open bin code v1 source, then Liberes, it's just a simple account. So what I did was mm, tide interface. Let me show you tide interface also. So that's important. Tide interface account. So this was the account he was tide interface. Yes, this is the account. Yep. Yeah, so this was basically the account he created. Just a regular account. It's not directly at a token account, but it looks like a token account. You have the mint, the owner, amount, delegates, state, padding, padding, the native amount, delegated amount. These are all the data I stored in the account. So he used RPRC to arrange them in order of the order of decreasing magnitude in descending order. So um, forget about that. Let's concentrate on this. It enables some features. So if you are using bin code 1, you should use deserialize and serialize from bin code. What is it? Deserialize and serialize from bin code 1. If you are using the bin code V2, you use decode and encode. If you are using Bosch, you use Bosch deserialize and Bosch serialize. So Bosch is what Anchor uses. If you're using Bytemorg, you use copy, clone, code, and zeroable from Bytemorg. If you're using WinCode, to write this account as WinCode. Yeah. 1 minute. Can you welcome that? Oh yeah, you muted now. Today, okay, I muted the audio. Let me while you can you mute your mic a bit? Can you mute your mic? Your mic is unmuted, so I just need feedback. Let me see if I increase. Can I see your oh, yeah, you're making yeah. So win code byte mark. So this is the win code example instruction. So this one is being code v1 rather. Just a basic entry point. Still using Pinocchio though. This is still Pinocchio instruction. And he loaded this an account is account borrow and check serialize, blah 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 blah. So what he's doing in this instruction is just getting token account as an account that I created previously, right? And it's putting setting the data from this account that I pass here. So what it's doing is just loading the account. It's loading the here and it's reading the data of the account and it's setting the state of the account, setting the state to 55 and the amount to 1000. So what he's doing here is this amount is putting a lamp port inside the account, setting the amount to this and setting the state of the account to that also. That's what it did here. State is 255 and the amount is this. And it just mutated the account of borrow mute, then it's serialized data. So this is what it's doing with different variants of the program. So when you're dealing with bin code, V1, he used 356 CUs. When he used Bosch, he used this. So let me check what he did with ByteMock. I like ByteMock, so there's no way I'm not going to ByteMock. I'll show you what I did. Trying to point out how Pinocchio lifts does a lot of makes things easier for your program. I was talking about ByteMock, not your input. ByteMock, ByteMock. Yeah, yeah. So refresh this one. I don't know what's going on. Internet. Okay, internet. Yeah. So with ByteMock, I need to close that window. With ByteMock, I have token account. ByteMock tribe use my so the ByteMock is just if you sane, this is what people that are sane would use. I don't know why you would do it. Oh, yeah, I plus that. Just try from byte mutable, then get as account structure. Just might not make your life easier. It does all of the heavy lifting for you under the hood and just gives you a simple interface to your site. So and it's saying if the token account is blah blah blah, stating changing the state and changing the data also. Yeah, basically, basically that's just what it did. And with ByteMock, this is just the benchmarking. This is benchmarking. So if even if you are using Pinocchio, if you are still using something as heavy as being code, that's if you are using something as heavy as Bosch, you are doing the same thing that Anchor is doing. So there's no need using being code. There's no need using Pinocchio in that sense. If you want to use something that is light for your serializing, for your passing for your decoding and encoding. I'm not even doing decoding and encoding. For your like I call it there's the word I'm looking for your serializing and deserializing data in that sense. So deserializing and serializing data, you want to use something light, so like ByteMock. I mean, I like ByteMock. And yeah, so let's get back to what we're talking about. Yeah. So this is the so you see this anchors deserialize and anchors serialize uses Bosch under the hood. This uses Bosch serialize and Bosch serialize. And see how heavy it is. So a minimum of 200 CUs just for this passing, just to take in a U16. You use 200 CUs already in this place, theoretically. So for Anchor, but with the new version of Anchor, there's going to be a lot of they are going to port a lot of things. They're going to make Anchor more efficient. So as efficient, almost as efficient as Pinocchio. If you want to watch out for Anchor 2.0, 2.1. That's but we're still on. I think Anchor is still on 1.0. Maybe release candidate or something. Let's check. Anchor version. The stable version of Anchor is on 0.32. Anchor lang. This one. Uh, uh, Then if I check the should be here, 0.32. That's the latest release 0.32. It's not going to version 1. So you get version 1 needs to be a bit stable, and after version 1, yeah, we bringing Pinocchio under the hood for Anchor, so Anchor will be as efficient as possible. Basically, so it's a win-win. So at that point, even if you're using Anchor, you're still writing efficient programs, right? So your program will be fast and cheaper. Yeah. So let's see. What else? Let's get started. Let's get the party started. Get the party started. I'm not even my own feet. Why? I don't know. I mean, I'll try to check something here. All right. So let's see. We started writing the Pinocchio variants. But before then, let's check all other instructions, right? So let's see. The first instruction, I already explained what's going on here. We created the global states. From this global state struct, let me just push that source state global state rs. So it's just the global. This is the config of the program, right? Basic. Everybody knows how to do this, right? So you have a global state account, which will be created as an account later on. That means you're just setting things inside the account, basically. Then for and by using it here, and they see this B global state as byte. Then the treasury account. After we've gotten all of the accounts, the token means the treasury accounts. We just set those into, we write them into the global states account. It's setting up. Yeah, so that's basically that instruction handler there. The next instruction that we're interested in is the in order of progression, create streamer. So the create streamer is also similar in the sense that we have a state also for the streamer state. The user wallet, token account of the user, and the pump of the user. So those are the three things that we're using. Our storing. So this streamer wallet is going to be the authority for the token account that is created for this streamer wallet. So we want to look from that token account. This will be the authority. But when we get it, let me show you what that looks like. Streamer. So the important thing about this program architecture is that it was built to sponsor users gas fee. That's the interesting thing about this program. It's basically an escrow, but a gasless escrow. So this is the twist. You send a program. Let's say you want to send a transaction. You want to a transaction on this account now. You want to withdraw from your account, or you want to do any transaction. You don't want to be the one to pay the gas for that account for the transaction. So this is the project it was created for. Switched. I did the project it was created for. 1 minute. Let it load up. Let it think about it for a minute and load up. My internet. I'm in a remote area. Yeah. Yeah, this is the platform it was created for. It's a live streaming platform. So a live streaming platform or regular users, you don't want to pay gas to make transactions, like you just want to use the platform created for. And flow is just simple as that. It comes to someone is streaming, you want to tip the user. The user already created his profile with the create streamer profile. Then as a user, and you want to tip the user. So you want to tip the user, you probably have maybe USDC or USDT or USDG token is supported currently. So if you tip the user now, you don't necessarily need to have sold to tip the user. You just send the transaction over, and the program handles the fee they are paying. So there's still a loose end on that part. Let me show you what I mean. Is it here? Is it here? So that's why we have two signers here. So the first signer is the owner of the account, and the second signer is the one paying the gas fee for the account, right? So yeah. So we have this broadcaster that is making the transaction, that is broadcasting the transaction for the signer. So this is the one paying the gas for the instruction. So this is the streamer state that we're creating. This streamer account that we just showed. The streamer is so initialize if needed. There's some reason why I did it that way. The payer is broadcaster. So this is the one paying for gas for all the transaction. The space of the account is the discriminator length plus the init space. We already know how to calculate size space now. Then the seeds is the user and the signer. So that's the owner of the account. Then token means it should be, want to make sure that the token means that the user provided is the same one as the supported token means in the global state. So now the token ATA, the ATA of the token account of the streamer. So init if needed, payer is still the broadcaster. Associated token mint is the token mint. The associated authority, so the authority of this account is the streamer state. So the streamer state can sign transaction on behalf of this account. Then we have a global state. That's the global state that we created initially. So now we're not initializing, we're not creating it yet because we're just we're reading the data of supported token mints. Basically, that's what we use for there. And we just create a streamer account. So we create a streamer account, we set in a blah 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 blah. Basically, that's what happens there. Then inside the source, let me get to the next instruction. In order of occurrence, tip user want to withdraw. Yes. Oh, sorry. Before we withdraw, you need to tip a user. So we tip a user, tip a streamer. So this is another account, right? So an external account from whatever. You are making the transaction here. Okay, sorry, you are the signer of the transaction. Then the ATA, your own ATA. We're making sure that your ATA, your token mint is the same one that's supported. And also making sure that you are the owner of the account they are passing. All these are the client side, but just for credibility part to make sure your program is not exploitable, right? So for the streamer ATA now, the streamer ATA, that's the person you're tipping. You want to make sure that the streamer ATA is the same supported one. The streamer ATA owner is the streamer state of that account, of that streamer. So we are passing the streamer account as a param here in the instruction. So we have this tip param, which is here, shows the amount you want to tip and the streamer pop to the tipping. So that's basically it. So then the streamer ATA, I'm making sure that the ATA is, where was I explaining? I think yes, to here. That's the param. I'm making sure that the global state token mint, streamer state, same thing. We're also making sure that the key of the streamer ATA, the copy of the streamer ATA is the same token account of the streamer state. So then token mint, streamer state, global state, all the regular accounts that were used for the validation. Then we just handle the tip. The tip is just a transfer. So it's a transfer checked instruction accounts. These are the accounts for this transfer check instruction. The authority of the transfer, that's you from your account, your ATA to the streamer ATA. The mint token mint will make a transfer, blah 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 blah. Transfer check, blah 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 blah. Sorry about that. So just basically this is Anchor. Everybody knows Anchor already. So I was trying to breeze over it. Then the next thing is what's next in there? Next instruction is actually I've not got the instruction. So let me put this down. Let's talk about it already. Yes. So now withdraw. Let's talk about the withdraw instruction. So this is where the magic happens. So because we are sponsoring the gas fee, we want to we want to get our gas fee back. Because I'm sponsoring your gas fee, you don't have to pay Sol to me. I want to get the equivalent of that Sol in gas fee, that gas fee in US in the token amount. Let's say let me Excalibur. Let me use this blank canvas. This canvas here. So let's say this is you, the user. This is our platform. As a user, you are making this. I just touched the arrow. One more. This one. Aha. So this is you now. This is streamer. This is user. Let me increase this a bit. Give me a cell. Okay. This is the user. This is the platform. So now, when you are making a transfer, we are not collecting. Normally, you're supposed to pay Sol, right? You're supposed to pay Sol as gas fee, right? But we are making sure. One minute. Just the yep. So you're not paying Sol as gas fee, but you're going to pay us the token. So you're paying us USDC as gas fee. So that means an empty account can come and make a transaction and you don't have gas fee, you don't have any Sol in your account, but you have that token in your account. So you can use USDC as gas fee. So the way we are doing the calculation is you're going to pay us gas fee plus our platform fee. That's basically how it works here. You're just paying gas fee in USDC plus our platform fee. So everything you are doing is totally in USDC. So how do we know the amount that this transaction is supposed to take in gas fee? For the moment, the program does not know. The program does not know, but the client knows. And also, how do we know the rate of USDC at the moment to be able to calculate? Okay, you have this. How do you get the tax rate of USDC? And multiply it by the amount by the rate with Sol to get the total amount of USDC in gas fee, right? We were supposed to practically would have used an oracle to get the token of the price of USDC at the moment, but at the moment it's still on the client. So what we do there is this. Let me show you what we did there. Yeah, we're receiving it here, streamer it here, token mint, global state, uh, treasury account because you have to pay fees to treasury account, streamer states, all the accounts that we need. So what we're doing here is user tokens. That's the streamer ATA. The person I want to withdraw now is the streamer actually. So the streamer ATA. Then the fee in USDC is coming from the client. What we did is in the tests, I have a little, yeah, I have a little test program. Okay, there. Just know we have we're passing the gas in USDC from the client. So what we're doing now is platform fee is over 100 times platform fee. That's just percentage, right? To get the percent of to convert out to percent. This is yes. So basis point is out there. Basis points. Everybody should know basis points now. Let's have one. You don't know basis points. Basis point is a better way to do percent in mode without using decimals. So what just do is add two zeros to the back of it. So let's say I want to do there should be a table, basis point table. The table will explain it better. Basis point table, yeah. Yeah, cool. So if I want to use a transaction, I want to take 0.1% on that transaction. Because I'm using basis points calculation, I'll just write one. So one is 0.01%. If I want 1%, I'll write 100 in the transaction. If I want 1.25%, I'll write 125. If I want 150%, I'll write 1. If I want 1.50%, I'll write 150. So that's how basis points work. So just you can start it off at 1% is 100 basis points. Then 0.1% is 10 basis points divided by 1. So 0.001% is 1 basis point. So that's the least you can go, 1. So just it's a trick from the finance world to use the amount of decimal overhead that you do in calculating large numbers. So if you want to say 10% of the transaction, what you're going to pass in the basis points is 1,000 BPS. So I hope that does justice to basis points, right? This way is just simple, straightforward. If you think of it like that. So yeah, that's about this is 100. So if you want to calculate um, your fees, let's say you say I'm taking 20% of a fee. What does 20% mean? That's 20 over 100 now. So yeah, that's basically what it is. So if I'm taking 20% of 20% of 1,000 naira, so that would be 20 over 100 times. Sorry, yeah, 20 over 100 times that 1,000, right? So that's basically what we're doing here for basis point calculation. Yes, let's see. Move this transaction fee. Yes, you are getting transaction fee from the params. Then platform fees. Params that amount. Let me check. Yeah. Yes. I'm sending the gas in USDC. Then the amount the user wants to withdraw. So those are the things we're passing in from the client to this instruction. Then we do you just multiply platform fee. This that I commented out here is what I did here. So platform fee here is the amount multiplied by this platform fee, this one. Then we divide it by 1,000, 10,000. That's 100. You get the idea, basis points. So platform fee, so that is amount times, I did multiplication first. So amount times platform fee over 100. Because I'm storing the part, let's say I'm storing this, the platform fee is in, let's say I wrote, I want 1% now. What I wrote in the platform fee here is 100 basis points. So I need to calculate that, the amount times that of 100 in normal calculation, normal percentage calculation, right? So that's basically what we're doing here. So it's just simple arithmetic. So now the next thing is I said the user receives the amount subtracted Okay, amount minus the transaction fee in USDC minus the platform fee. So that's what the user receive. When you're writing instructions like this, you want to have a mind map inside. So when someone is reading your program, they understand what you're doing, right? So he said the other amount the user receives is the amount he put in, I want to withdraw, minus the fee in USDC, transaction fee in USDC, then minus gas fee in USDC, and minus our platform fee. Yeah, our platform fee is this one that was calculated here. Set it by the amount they want to. So like let's say I'm doing 0.5% right. So 0.5% of the amount, that's platform fee, 0.5% of the amount. But not 0.5 for Wise, right? So after I know the amounts the user wants to receive, then I did it here. So the amount that will be sent to the platform is the fee in USDC and the platform fee. So now we already have all of those in variables. So we now do a validation check, ensure that the amount that user puts in is the user has sufficient balance basically. There will be the transaction. We are doing two transactions, right? One transaction to the platform for fees, and that transaction to the user that wants to withdraw. He wants to withdraw to a different account or whatever. Yeah, so that is what this one is. So this first one is transfer to user account. So they want to withdraw to. From is the streamer ETA, authority is the streamer state, mint is this, two is this, then to the treasury account also treasury. So from is the streamer ETA, platform streamer ETA, the authority is the streamer state, the mint, and we are transferring to is the treasury account here. So now we build the seed of the transfer, the seed for the transfer, the seed of that streamer state. That's the user, the signer, and the bump. Then transfer to user CPI. So this is the CPI location for building the CPI context for the location to transfer to the user. So new with signer because we are using PDA. I'm going to put the seed here. So what program what program are you interacting with? I'm interacting with the token program. Then we're transferring. This is the instruction that we built here. Transfer to user account, the account rather. Then for the treasury, just put the treasury, this one that will be also. Then we transfer, make the transfers, and that's all. So all of the magic I said, that is just what happens. So just walking you through that. And next thing, after the withdraw instruction, so if the admin wants to withdraw all his fees also, that's even straightforward. Just we want to make sure that only the admin can withdraw fee from the admin account. Important. They also want to make sure that the amount that wants to withdraw is sufficient. The admin sign, blah, 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 blah. All the fees, all the so just get the total balance of the account, then withdraw the account, withdraw the balance. And if you want to close, they don't close here because you still want to maybe still for other things, right? So you don't want to close the token account here. And that's basically it. That's basically everything that we did for this program. So yeah, let me now start replicating it in Pinocchio. We have started writing Pinocchio already. Yeah, I was explaining token accounts here, the program accounts. Clear this. So I just see the Solana, see the documents. Solana. Where did I put it? I think it's Pinocchio. Then switched. Yep. Yeah. So Liberes. Where do I start from? So if you were not here on Monday, then you create the font. If you were not here on Monday, I'm trying to see how to do a quick rollback so you can follow through what we're doing here. What is Pinocchio, right? Just know, don't even just know. Let me break it down and explain everything as much as I can. Mm, so, for every instruction, the way instructions are built, Pinocchio forces you to think of Solana for you to understand how Solana instructions work. For you write instructions, so Anchor just abstract a lot of things away from the picture for us, right? But Pinocchio wants you to understand what's actually going on as an engineer. So, if you are sending an instruction is basically the ID of the program communicating with, the data you want to pass to that instruction, and the accounts that are involved in the instruction. Those are basically the three things fundamentally. Sometimes you have to pass some as account meta, some as account info, some as blah blah blah. Fundamentally, three things that are involved in the instruction lifecycle is the instruction, data, the program you're communicating with, and the accounts that are required for processing action. So that's basically what the Pinocchio instruction entry point is. So this is the entry point. Entry point to the whole program. So this is the tree that's, let me show you what that's look like in an Anchor program. Source, then DBRS. Yes, an Anchor program, this is what it looks like. You have this program entry point. So this is your entry point. This program macro is injecting the entry point into your whole program. So you have program, pub, multi, blah, 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 blah. So you now have all the instructions that are communicating, all the instructions inside of it. Crestoma, Tipita, whatever. So that's the same thing that's going on here in Pinocchio. So this is process instruction, the entry point, then the program ID that are communicating with the program, the accounts that be needed for the instruction, and the instruction data. When you get to know Pinocchio, you'll see that it just feels natural. But before it feels natural, to understand what's going on there. So let's see. So every instruction, so this instruction data now, and for the instruction data, thing in the instruction data is the discriminator of the instruction, right? That's how we want it to come in our program. If you want it to be the other way, let's say the fifth byte, you can. What is stopping you from making the fifth byte in the instruction? But normally, the first byte of data they are getting is the discriminator of the instruction. What is the discriminator? The discriminator is just an indicator, a pointer. Pointer is a wrong choice of words there. It's a marker. Let me use the word marker that says I'm interacting with instruction 0, I'm interacting with instruction 1, instruction 2. That was a discriminator is, right? So the custom discriminator for that instruction, that was a discriminator is. So from my instruction data, we are splitting out the first instruction, the first byte. Basically, everything that are passing to your account, to your program, on a bytes is an array of bytes. It's just so this is a slice, a byte slice, and a byte slice array. It's an array of bytes with an unfixed length. Yeah, yeah, that is there. It's an array of instructions with an unfixed length. That's basically what you're passing to your program instruction and instruction data, right? So that's what you should know. Everything is bytes. Everything is bytes. So when you get to understand and come to terms with it that everything is bytes, Pinocchio, right, instruction just feels understand instruction on the base level, on underneath makes more sense. So first thing we remove the discriminator from the instruction data, and every other thing that is coming in is the instruction data. So if you are passing to an instruction like this one, source instructions, let's say withdraw. Yeah, so this withdraw instruction, you see we have these parameters. This is the instruction data. So in Pinocchio, for us to use this instruction data, we first need to, this is what Anchor is doing underneath. It's converting this to bytes because it can only work with bytes. To convert this whole thing into bytes, and it's fairly easy. It's fairly easy once you understand it. So we need to find a way to convert this whole thing into bytes so that Solana virtual machine can understand. Because your program does not see what a withdraw param. It doesn't. Solana doesn't understand what this withdraw param is. This is Rust. On your program, on your computer, if you store this on your computer, what you are storing is a a a heap of data, right? So you are storing this to this byte array. So the first byte is a U64, the next byte is a U64. It's just two U64, two U64s beside each other. That's basically what it is. That is exactly what it looks like. You save this when you load this as instruction data. What it should be converted to is where's my schedule? Yeah. Or what is converted to is this. We have this guy. We have one other guy. I have that same guy again. So this is what is loaded into your instruction. This is just what. So for you to, the reason why you are creating your struct is basically for you to know the position it is in memory. So when you have a pointer to it, you can now say, okay, I have a pointer and I'm getting a struct of. Let me show you that. Let me bring it closer. So I'll not be moving around too much. Yeah, this one. So yeah, basically saying if I'm pointing to this withdraw params has a size of U64. What is the size of a U64? U64 is 8 bytes. 8 bytes. So this one is now 8 bytes plus another 8 bytes. So that's a byte array of eight length. Let me show you that what that means. Explaining without drawing is tedious. It's not tedious than explaining with drawing. So you have the U8, the U8, 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 U8. 1, 2, 3, 4, 5, 6. The U8, U8. 1, 2, 3, 4, 5, 6, 7. One more. U8. So this is that U64 that is represented in your code. This is what it looks like. A U8 array of 8 size. So that's 8 times 8 is 64, right? 8. So the base, yeah. So if you are telling Solana program to go and look for this struct in memory, load it into your instruction, your stack, it would it's just a pointer to the size of this. So that's just basically what it is. So it's not like it's storing your struct and knows what a struct is. The struct is just for you to understand what's going on. Because else you just be writing assembly or, or something low level, writing the bytes directly. So yeah, this gives more sanity to the developer, but this is not stored inside your program. What is stored is bytes. Like I showed you previously, that program that we inspected. Now let's inspect again. You see what is stored there is bytes. So this is just bytes. This is what is stored. It does not know what if you are saying like a struct or not a struct. Does not give a shit about that. What is stored in your program is just these guys, right? So and where it is in memory. Let me clear this out. So yeah. So let's get back to the interesting part. So why is there a chicken? uh, yeah, yeah. I digressed a bit. Let's get back to Pinocchio. That's what I was explaining. I've already explained the anchor part. So now I'm trying to port that anchor program to Pinocchio, and I'm trying to explain as clear as possible, so it will be natural when you start writing code. So I have this first discriminator, like cutting discriminator from the instruction. So when your instruction is coming, I need this in another, this in another. That's like where's my escalator? I need this in a different slice. Let me move this place. Yeah, so I can slide. Yeah, makes sense. So when you are passing your instruction over to anchor to wherever, I say split the first byte. So this first byte will be your instruction discriminator, basically. So everything you are passing to Solana as instruction data is just a long array of this U8s. So this can be, I think the highest value of a U8 is 255, right? This can be 10, this can be whatever it is, right? So and this should be correct. Yeah. So the length is not fixed, it's just a long byte. And so if you are saying this first instruction, this you are splitting this first as your discriminator. So that means when you come to this instruction, when you come to this instruction, the discriminator is 255. So I want to communicate with instruction 255. So in this case, I want to communicate with instruction 0. So I'll communicate with instruction 0, right? So that is instruction 0 is switched instruction initialize. So over on this, you see, let me go to switch instruction. 1 minute. So I created this struct to help make, instead of, if I don't want to create this struct, I'll have just been writing 0, 1, 2, 3, 4, 5 inside this libres here. I would have just said discriminator. It should have looked more like this. Looked more like this. Match discriminator. Then if it's 0, do process initialize data. Yeah, it should look like this. If it's do whatever, then if it's unknown, return this error unknown. Yeah, this is what it would have looked like if I did not want to use. This is actually cleaner though, but for this is not. Is it cleaner? You decide. This is this is what it would have looked like if I didn't want to use uh this helper here that I'm converting the this instruction and last to an enum. I created an enum for all the instructions. So the first instruction is initialize, create the streamer, tip user, withdraw, admin withdraw fees. All those are all the instructions um, inside this program here. If I go to Libres, not wiki, not wiki, not wiki, not wiki, not wiki. Citron, I come to programs, Libres in the source. Yeah. I come here, you see all the instructions there. 1, 2, 3, 4, 5, 6. So that's the same thing there. 1, 2, 3, 4, 5, 6. And why do I have this representation of C? RH we went through, let me show you again. Let's just search online. RAPRC, what does RAPRC do in so it just means align the same way C does. Does RAPRC same thing RAPRC, RAPRU8 do in Rust, memory layout, blah 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 blah. So RPRC attribute in Rust specifies that a type use the same memory layout as it would use in language. So ensuring that the order, the size, and alignment of the field match what it would produce. So the same way C handles this, handles it the same way C handles it. So if C handles this in order of increasing size, handle it in the same way. So if I put RPC here, same thing, wrapper U8. So now I'm doing it in order of increasing magnitude. So Z, Z, Z. So now we can see if I go on this initialize 0, create 1, set user is 2, and I remove the office is 5, so 1 to 6. Same thing that we did here. Yeah, so let me get back to Liberes. So I don't want to do this. I also wanted to make it look more readable. That's why we're using this match here. And try us on discriminator, then if initialize, call this process initialize method. And that brings us to the process initialize method. We have written all of this on Monday, if you're not here on Monday. Let me just silver, that silver, let me just allow unused. Allow unused imports. I think yes, we should go. I put it here also. Yeah, that should go. Unused variable. Used variable. I think this one is just annoys me. Okay, on top of it. Let's see. This is not a variable, it's a function, right? They're unused function. Allow unused. Oh, let's just allow unused should. Yeah, that works. So if I come up and put it here, it works. Okay, so yeah, what this does, this is just a function basically, right? This is a function. Let's ignore all of these parts first for now. Let's pretend that they do not exist. So process initialize is a function that handles the creating. So what this is doing is the exact same thing that 4 minutes. Sus. Come on, work with me, work with me, work with me. It's taking forever to load. Source instruction, global status. Yeah. Bro, internet is killing me right here. I need a Starlink. Excuse me. So the same thing that we are doing here, that we just want to do the same. This is anchor, right? Undo initialize, press initialize, whatever. So then we are taking this params, which is this initialize param. This is just a U16. That's an array of two U8. That's 8 times 2 is 16, right? An array of two U8. So I'm taking that in here and the bump of the undo initialize. So that's basically what this instruction is doing. So that's what we want to replicate here with Pinocchio also. So the first thing, we're getting all of the accounts. That is what this is. So all of our initialized global state designer, global state account, treasury account, token mint account, system program, architect token program, and token program. Those are the same account that we're using here. This one just makes more sense. Signer, global state account, token mint account, system program, architect token program, rent silver. I'm using rent silver for a reason. I'm using rent is bad because I don't want to do rent get. So if you wanted to create an account, basically, okay, here's what I did it here. Where's the rent account? Rent account, minimum balance. Yeah. So I'm doing rent from account info instead of rent get. So this get here is I think 100 CUs, 100 CUs. So I want to not use those 100 CUs and just load the instruction from the rent account that you pass to me from the client. So I just utilized and wrote smarter program that way. So instead of let us get it of ourselves. Okay, so the first thing I did was load all the accounts. I specified I want exactly 1, 2, 3, 4, 5, 6, 7, 8 accounts. If if you provided more or less, it will tell you this error, not enough account keys. Hmm, ignore this for now. We did this later. Okay, let me just show you. I'm using, like I said, I'm using ByteMock instead of again Fibo made this tweet. ByteMock for that account that he showed would use 40 CUs. But if you use Bosch to deserialize that account, this is where is it? Let me show you. Should I still show it? Let me do it again. So I could have just got in. Yes, time loaded. Oh, it's taking this time. Take your time. Take your time. Do your thing. So in the interface and the source libres, yep, he provided all of these different features. So if you enable Beam code V2, it will deserialize this account. This is just the account here. So this account has a mint, a owner, amount, delegates, blah 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 blah. It has all of this. It's similar to a token account. So it means this token account, right? It's just token account. So what you did here, similar to token account, not token account. What it did here was, if you loaded this account, just load the account and write some data to it using Bosch, using Bean code, you would be consuming 356 CUs. If you used Bosch, you'll be consuming 617 CUs. If you use ByteMock for that same instruction, 40 CUs. Transmitter. So I'm using ByteMock for everything on this Pinocchio here. I'm using ByteMock. So that's why I'm using ByteMock here. So what I'm doing here is ByteMock and try pod read online. What pod means is a plain old data, a plain old data account. Plain old data is used for you in what plain data, whatever data. So those are the kind of data that are inside this struct, right? So try pod read unaligned. Then we have light switch is I should have yes, this is switch is just this pub fee basis points. The fee in basis points is U16. That's the same thing as where is it? Where is it? Switching tabs. Same thing as this guy here. So but instead of using anchor serialize and anchor deserialize, I'm using pod zeroable clone copy pod zeroable. I can remove this debug is just for printing. I was not even printing it anywhere. So I could remove what I just needed was this pod zeroable and copy. I did not need to clone, debug, and partial. I'm not printing it anywhere. Yeah, so I can remove all of this. Yeah, so that's what I just did to serialize this account. So I can now, since this account is off, a type that ByteMock understand, I can use ByteMock to read the account as this type, not an account, read the struct as this type, and passing the data of the struct. Right. So the data now is just instruction data. Remember, we split off the discriminator from the instruction, then the rest that is coming with that instruction data is the instruction data, the data that we want to pass to this account. So if we're calling this initialize process initialize, what we're passing to it is a U8, just an array of U8. So now the first array of U8 that we want to use, where is it? No, initialize. There you go, it's moving too far. Yes. So I'm saying read only a struct initialize switch. And what that would do is basically it's a U16, right? What this would do if we do not want to use byte up there, so it would have been, let's say, let's ix data and is to a equals now be data then from 0 to what's the length of a U16? 2, right? U16 is 8 bytes. So yeah, that's what this will look like. Size of blah 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 blah. U16 of type U of type U8 2. I think that should be sorted. Found U8. Yeah, should put this into. Is it there? Dot read from yeah, I think I'm reading all of the data from this. Expected U8 to found U8. Let me do as can I cast it directly? As let me see if I can cast it directly here. No, I need to do something else to make it understand. It knows that I'm getting this, but it is still, let me see. Okay, if I borrow it in slice for data, it will not. It knows that I'm getting it as an array, but because I'm not specifying the length of the array, what it's complaining about, I need to specify the length of the array. Can I do it too? Yeah, that will not work. Yeah, that will not work. It will not work. So yeah, but that's what it would like. Let me see. So I can copy. Let me copy into another array. Let's some array equals an array of 0 as U8, then 2. Yeah, this could work. Then I will now do instruction data equals some array dot from is it copy from there? Copy from slice data from 0 to 2. I think it should work. I think. Yeah, this mass type font. I think I need to do this on it. Okay. Found at reference because that remove the borrow. Yeah, remove the borrow. What's the problem again? Yeah, I think it wants me to unwrap. Let me see that unwrap. No, there's no unwrap on it. This should work. Consider borrow. I just borrowed. It told me not to borrow. Bro, that's twisted. Copy from slice. 1 minute. It wants me to do something after this. Is there anyways, let's do that. So this is what it will look like. If I coded this, it will just give me exactly what. Let me just let's vibe code it because why not? Yeah, by the way. Let me see. Open a new Claude instance. Claude AI. Open a new Claude instance. Then open a new chat. Then close this one. Hello, dear sir. Please help fix this. I just needed it's just something simple that I should. Doesn't return anything. Okay, I should do. Oh, yeah, that's true. Coming from slides does not return anything. I was assigning. I thought it was TypeScript. So yeah. This is what I should have done. I shall just summary the copy from slice data, then ix data equals summary. Like, bro. So I was not supposed to assign it. I knew I was doing something stupid. So if I just did instruction data, would not be. Let me move this up. Yeah, yeah. So this one will now be summary. I think that will work. Data to consider borrowing. Yeah, I like borrowing again. Yeah. Sorry, it's not mutable. That's the problem. Mute, mute, not my use. Aha, so that worked. So now we now have our instruction data. These three lines would be, that's what this line is doing. Try equal blah 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 blah. So just to get, because we know this one now, because we know that we're expecting a U16, and U16 is just an array of two, it's by 2 bytes, two bytes, an array of 2 bytes. Now we know that we can go from 0th index to length 2 and just pour that inside instruction data. Yeah, so that's that. But instead of doing that, let's just use bytemap to read it directly. Yeah. So if there's an error when copying this, it throws an error in value instruction data, blah blah blah. So next thing we're now doing is checking if it's a signer. So asserting that the signer is a signer. So before I wrote all this instruction, I first did this. I wrote all the comments out in single lines. I did assert this. Let me check if I have the git history. Git history, what is history? A minute. Let me look for history a minute. Yes, this guy. So that was how many days ago? That was, let's see, file saved this one. What is this one? No, it was probably this one. This one. It was probably this one. This one. Almost. It was this one, I think. Yeah. So I commented all this now. Assets. Then all the assets, all the steps I wanted to take in the instruction, I commented them out first. So you first think before you write. So you have a roadmap, you have a planned roadmap that you want to follow before you start writing code. Yeah, that's just what I was supposed to point out. Let me increase the font of this back. Yeah, so after all the instruction I wanted to do, then we have we check the signer is a signer because an account info. An account info is coming from Pinocchio, not Solana program. So I'm not using Solana program, I'm using Pinocchio. So account info is from account info. It's similar implementation, similar name, but different implementation. But it still does the same thing in the Pinocchio way, in a zero copy way. By checking that the account that you're creating is empty, because the account has already been created, why are you creating it again? Then we are now reading. So we have a mint account. Yes, this token mint account. So use a mint from account because it's just an account info. An account info does not have mint information, right? If you check what the definition of an account info is here, an account info is just is signer, is writable, executable, sellable data, owner, lamp ports, data length. Okay, sorry, account info. Yeah, same thing. Same thing as accounts. That's what they're saying, yeah. So we cannot know if an account is a token account from the account info. So we can cast it into a token account if it is a token account or a mint account or whatever account it is from this same. It's just like using bytemap, like what we did here using bytemap, right? So you can use bytemap, try for read line and specify the type of account you want to cast it to. So that's a similar thing to what's going on here. So I have a mint struct here. So I will do mint from account info, pass the account info, yeah, token mint, because that should be an account info. Then we are now reading, to make sure that the token has 6 decimals, and also checking that the Token account is of the mint. That means the token mint is equal to token account mint. So that means the token mint you are passing here is the same thing as this token account mint, this token account statement. So that means I'm telling the instruction that when you are creating this instruction, when you want to initialize, this is the mint that this thing should use. And I'll pass a token account. So I want to make sure that that token account passing is an ATA of the mint. It should not be a different ATA account. That's just the total number. Then mean that the PDA of this global state that you computed off chain from the client is the same thing. When we compute it on chain, must be the same thing, right? So that's what we did here. We just did pub key, find program address. I'm doing this because this is one-off thing. So I'm not finding program address every single time. We're not doing that computer, just doing the one-off here because we're creating the account. We want to be sure that the account you're passing from the program side, from the client side, is the same one it is here. So that would be an equivalent of what Anchor does with init here. If you're initializing this, so if you create an account, if it's not an init account, let's say in the future it's not an init, it's just a mutable account, then you pass in the space. You need to be sure. Anchor will check. Anchor will give you an error that you created an account with the wrong seed. This is similar to what they did here. So they are computing that account, like, and they are checking it against what they create on chain. If it is wrong, they tell you you created an account with the wrong seed, expected this, provided this. You have seen that error, right? So that's basically what this this is here. Then we're getting the rent information from the rent account sales pass. Then we're just getting the minimum balance for that account's length. So the global state is like I showed you. Okay. Let me start from the state before getting to instruction. So this state account, yeah, I should have done the state before getting to the instruction. State source, then states, then global states, then yeah. This is the pub key is a use16 fee, the basis points, fee in basis points, then the platform fee account, the supported mint, the bump, and if it's initialized, we don't care what we do. So the same thing here. I could have written pub key here. Pinocchio pub key. Pinocchio pub key is just a byte. So I could have written pub key here. Like I literally could have just pub key. Sorry, my bad. I could have used pub key here. But I wanted to illustrate, and I like manipulating the bytes, not directly, but having a sense of what's going on. That's why I know it's pub key. I used the side of pub key. The pub key is just an array of bytes which are located. So that's what the pub key is. So this is a U16. A U16 is U8 times 2 is U16. U8 times 2. But we know how to calculate bytes, anchor bytes. We've done this already, right? So pub key here also is U32, 8, 32 length, 32 length. Then the bump is just one bump, right? But I'm still storing it as a byte array also here also. Then if it's initialized, also a boolean. It's the same. This is a U8. It's also a boolean is also a U8 sort of. Yeah. So that's basically what's going on there. I just created this struct this way. Then I'm using core memory, the size of this guy in memory. So this whole struct, we can calculate the size. That's 32 plus 2 plus 32 plus 32 plus 1 plus 1, and whatever that would be 100. So the size of this guy is 100. You could, for whatever reason, calculate it manually and do 32 plus 2 plus yeah. But I don't want to do. I don't want. It's just stupid things for stupid reasons, right? But I don't want to do that. I don't do that. So I just use mem from core memory of this. Does this consume more CUs? Does it? If it was if it was going to consume more CUs, it'd be like just 2 CUs or 1 CU, and it's just do it and use the 2 CUs. Like 2 CUs is not going to make your program slow, more expensive. Yeah, yeah, yeah. So I use this and 2 bytes. I'm only using 2 bytes outside of the program, not inside the program. So now I'm using a vector. I'm using 2 bytes outside the program, not inside the program. I'm using it in the client side, the test, client and test. So yeah, what this does just convert all of this to bytes using byte mock bytes off. I could have done it a different way for fn to 2 bytes, and it's still going to return. It takes in self and returns, let's say, a vec of UH still. Then if I wanted to do this, how would I have done it? Uh, uh, I think I would have done a. I'd rather see. I could have done self dot 2 bytes. Let me see. Will this work? I think this should have worked. This would have worked. Let me ask. Let me ask. Let me ask ChatGPT. Let me ask. This should have. If I don't think it will work that way. Would my 2 bytes? Would my two bytes work the same way as the 2 bytes? Let's see. Yes. That in the same way as 2 bytes. It's simply because 2 bytes and return the same result. So I just did, yeah, just like Jeff would say, always go over your push. Because there will be some stupid thing that you did. I'll be like, wow, I could have done this better. Yeah, it's okay. Side note, I noticed the typo in your struct. Platform fee should be platform account. Oh, plat, platform, 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 whatever. You get the gist. Yeah. So let's see. Let's see. Let's see. I'm enjoying this. Hope everyone else is enjoying it too. Hopefully. Yeah. Yeah. Let's see. What's this thing like? What's it like? What's it like? I can't see myself live. Sorry, give me 1 minute. I'm trying to see if I'm still live on the platform. The anchor found that. Oh yeah, I'm still live. Yes. Let's just continue. So this would have. I did not need bite mark anywhere here. Crazy. But if I use the pop key here, pop key is a byte also. Yeah, just forget about it. Just forget about it. So assume everybody is better to bytes because it's just immediately better. I can just talk about it right now. Like there should be a better way to handle this, right? Let me see. Again. To byte must byte off. Just call to byte and return the result. You can safely remove to byte unless you have to create to keep it like returning back of our waiting for that blah blah blah. This is redundant. You have two methods that do this identification thing. Blah, 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 blah. Yes, I know it's redundant. I just put it there to make a point, to prove a point, and I just proved the point. Yes. Well, I want to write some code before we get to talking. Talking. Dan is here. Dan is here in the chat, and I like to do. I like to do some chat. Am I listening to myself again? Is there a feedback? No, there's no feedback. We like to talk about the anchor mindset and all. But before then, let's still push. Let's press further. Let's press further in this. We I have all day, not all day, 5 hours, and we're like 2 hours in already. Yeah. So let's just. I don't have all day actually. If I keep going this week, I might not be able to finish this program, but I'll just keep talking and figuring out the silly mistakes that I did somewhere in the code, someplace. Yeah. So Basically, that would have worked. So let's get back to explaining what we're doing here. Yeah. Now, we also want to do the reason why we also did this was to get the bump. So the bump that was used to create this account, because we need to create the account somewhere in the future, and that feature is now line 87. We need to get that bump and to convert the bump to an early byte because I'm the bump as an array, not one, not a U8. I'm storing it as an array of U8. An array of U8. What would that look like? Let me see. Can I run interactive Rust in terminal? Let me see. Can I run interactive Rust terminal? If it was Node, I could have just done, let's say, Node. I'd have done um, bytes, bytes dot from, is it bytes or bytes? I think it's bytes, small letter b. Bytes dot from 34. Bytes not defined. Buffer, yeah, yeah, buffer from 34, 32. Eh, from, not from. Buffer from, not from. The first argument must be of type string and a sort of buffer. Okay, how do I convert? Okay, let me see. Buffer dot from hello, and I have this byte array here, but this is hexadecimal. How do I convert it to bytes? What else have I got? Dot 2 bytes there, 2 bytes there, 2 bytes. I don't think I know what I'm doing. But what I'm trying to point out is I need an interactive terminal for Node for Rust. But let me go to this point. I'm trying to make it unnecessary though. Let me see. Rust playground. Let's be a playground somewhere. Yeah, there is a playground somewhere. My connection was not interrupted. Do you need a VPN? No. Good. Thank you very much. Oh yeah, yeah. This is one messy thing that I was doing. All that doing stuff. All that. Ignore this. I was reading. I think I was reading the Rust book then. I was trying to play around with lifetime shadow. Ignore. Just pretend like you did not see all of this because you didn't. This is a mirage. Yeah. So yeah. Let me. All that I trying to point out. Let's new int was coming. All that I trying to point out. Moment. Sorry. Yes. Bump. I have a bump. This three. Right. So print ln print ln put this here new int in bytes. Think don't need this too, but let me just keep it there. And I'll put new int. Why is there no type format here? I don't know. But, so let me run this new int. I have three, right? So let me convert new int to early bytes. Let's just do it here. Dot to early bytes. Little endian bytes. That was this. We can call to early bytes unambiguous number integer. It's not an ambiguous number integer, but rather it is a U8. U8. Uh, yeah, so converting it to early byte just changes it to an early byte. A byte of a byte. Talk about into an array of bytes. Yeah, yeah, that's what that is. Let me overflow this. 256. Ha 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 ha. Muhaha ha ha ha. So here does not fit into the type range, blah 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 blah. Let me make that into a U16. Yes, in a U16, this 56 a U16 is now a byte array of 0 and 1. This is 1 is the next 256 plus 1, 255 plus 1, 1, 25. Forget I said anything. This is like 10. This is 10 in decimal, 10 in binary, right? When you convert 10 to binary, that's 10 because 1 times 10 is to the power 1 plus 1 times. This is totally unnecessary. Just it's now on the bush here. Print line. Let me print this. Sorry guys. Sorry for saying it. Print ln. I'm coming out to make a point. It's a totally unnecessary point though. Print line this. Let me see if it's if it gives us what I think it will give us. Blah, 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 blah. Uh, not save, don't save, don't save, don't save. Let me see. Uh, can't be. Oh, the reference. My bad. Times 10 raised to power. Does this does this work? Let me see. Hmm. Let me see if this one works in Rust. My bad. That's what I played out in my head was not that at all. Alright, let's get back to code. So just convert this to LE to little endian. I should have just said to LE bytes here, like bytes, and I would not need this. Bro, crazy, crazy, crazy stuff, crazy stuff, crazy stuff. Well, yeah, yeah, don't mind me. If I had done to LE bytes here, I would have not needed this array again. But no problem though. Let's assume I do some stupid things sometimes, right? So we have seeds here, and there's this seed. The way Pinocchio works is like I said, Pinocchio is a zero copy program library, right? We don't move things, we don't copy things. If you wanted to create an account in Solana program, if you want to pass your seed will be a three-dimensional array, right? It will be because you have an array of signers. A basic signer, a signer is of this type. You A signer is of this type. This is what a signer is. But if you have multiple signers, you need to put it like this. You have to put it like this. This is like maybe like a a how do you call it? A multi-sig, or they have multiple signers. So this is what a signer looks like. So to do this, we need to do a whole lot of for loop. We do a for loop on the first layer, for loop on the second layer, for loop on the third layer, expand that, and compute the seed on top of that. See, Pinocchio does not do that. Pinocchio gives you this convenience function. Is it convenient? The new methodology of thinking about it. So you have this seed from. So if you want to compute your seeds, you use the seed form. You can use the macro directly. There's a seeds macro. Seeds, seeds. Yes, macro. You just put in these guys. What you did there? Just put them in here. Well, no, I'm not using the macro. Let me use the struct itself. So you can do a seed from this guy, global state, then seed from the bomb. So that's just you computed the seed for the account, right? So a signer is now a signer from seeds. You have your seeds, then create a signer from it. It is of type signer, not a type of array. But if you see it here, it's still an array, but an array of seeds. not an array of U8. That's one thing you need to take note of in Pinocchio. We're not doing this three-dimensional for loop inside that for loop, put another for loop, then have a for loop. You get? We're not doing that in Pinocchio. We're doing just the signer and the seeds. Yeah. So you create your account here. So from who is paying for the account, the signer, the land port is the minimum balance, that is rent state dot minimum balance of the length of this account. So the global state has a length feature, that's 100, right? We did learn here is 100. So we need to accommodate on, we need to pay for 100 bytes, I think. Yes, we need to pay for 100. Is it bytes? Is it bytes? The size is 100. We need to pay for 100 here in the initialize. Yeah, comments looking for price. Yes, we are paying for the minimum balance that is required for rent for this account. So I'm paying for space 100, and then the minimum lamp that is required for that is minimum balance of 100. Yeah. Then the owner is our program ID. The space it will take is still that 100. Then the two is the global state that we're creating, right? So that's the account that is created. Then we invoke it. When you're creating a PDA, you use invoke sign because it's a PDA, it needs the signers. So you use to put the signer there. Basically, that's basically it. So we've created the account. The next thing we want to do is write to the account. This thing that we did here. Check your Pinocchio, sorry, your anchor example here. Need to go back to it. Source, instruction, global state, this one. Why are you messing with me? 2 minutes, 1 minute, 0 minutes. Bro, come on, just load up. It's not the end of the world. It probably is somewhere. Crazy. Nice base spelling. Yeah. So yes, I was saying. So we first created the account. We are not doing the creation inside the instruction here with Anchor. We could, but we are already doing this init here. If you didn't want to use this init, you would have just passed the account as it is. You remove the init, leave the account as it is. Remove the init, don't put mute. Okay, you put mute, possibly put mute, and the space for it. And inside of it, you will now do the create account. But with this init constraint here, this init flag, you are creating the account. You are telling Anchor to create the account for you. So when we've created the account, then we're now setting the variables, the struct. So setting the struct data, we're writing the data into the account. So that's what we're doing here. Once we've created the account, now we want to get that account and write to it. So we have this global state and try borrow mute data. So you are borrowing the data mutably. Whatever data is inside of it, 0 byte because we created the account, but now has 0 byte. So the data inside of it, we want to borrow the data there and use byte mock to write to it. If we did not do, if we're not using byte mock here, what this would have looked like is, like we said, to be state data dot copy from slice. So the first slice is what admin abi signer key. So signer key, signer dot key. So that would have been what we were doing here. So first copy from slice signer key, then copy from slice bump. But we need to be sure that that is the size of it. So copy slice bump, then copy slice this, copy slice that. But yeah, we don't want to do that. We want to do something sane, more sane, right? So we will just did convert it, use byte mock to get the data mutably, use byte mock to structure it because we already have a structure here of global state and we know the size of this one, size of this. So we have, when we use byte mock to get the data mutably, it gives us a reference to a global state, it gives us a global state structure back. If I do global state as state data, and I can do global state as state data dot admin, I can now have a dot admin on top of it because it knows the type of data, it knows the type of structure I want for it when I pass in the structure here. Dot admin is the signer key, Dot bump is a bump as byte array by byte of array and array byte array is initialized to one as byte array also. Global state of platform fee accounts, token accounts, dot key. So now we wrote into all of it. So like I said, for this place also, platform fee BPS. This platform fee BPS was this instruction data fee BPS dot by this one we wrote here. So if I wanted to do, if I don't want to use byte mock here, I would have done it this way that I commented, right? That one that I showed previously. I'll just get that data I with into this place. But since we're using byte mock, that is a lot of times point out. But since we're using byte mock, we just go with byte mock, right? So and also the supported token mints is also this. So you see, if we were not using byte mock here, we would need to save the data in the order that it is arranged because we created global state this way. And we say the first 32 bytes is admin, the next 2 bytes is the platform fee, the next 32 bytes is this. If we're not using bytes mock here, we would have to know how to arrange those bytes with copy from slice. The next one must be the same slice, else you have another data because data will just be unordered. Yes, you understand. So that's basically why we're using bytes mock here to give us sanity when writing and reading from bytes mock. Yes. Yeah, so that's basically all for this instruction, and I would like to proceed to writing the test. So we've done this cool. So let's write the test for it. So that's now writing code. After we've written the test for this one, if this test passes, then we'll break out for a little bit of chat. Yeah, who's ready? Who's ready for that? You already dropped ready in the chat. I'm sure nobody will drop ready. Priyansh, yeah, Priyansh is here. Hi, bro. How you doing, man? You already just drop ready in the chat. And developers are proud. Developers will not type. Nobody will type in the chat. That's the freaking annoying. Oh, yeah, I mean, Bola is here also. Yeah, bro. That's the freaking annoying thing about developers. Developers are too proud. They will not respond to chat. Okay, Priyansh has said something. I mean, Bola has said so they are ready. Who else is ready? Who else is ready? Let me see how many people are streaming first. So I'll catch you guys. I think we have, yeah, I mean, Bola is ready. We have, how many streamers? I think I have 18 or something. We have 23 people streaming, and just four people are ready. In fact, just 2 people are ready out of 32 people that are streaming, 23 people that are streaming. Like, yeah, yeah, yeah. Let's go. Let's go, anyways. Bro, proud of you too, Priyansh. Priyansh is doing amazing, amazing work out there. The guy is crazy. The guy is on steroids. Then this guy is doing things that I can't even pronounce. It's doing eBPF, it's doing quick, it's working with Fire Dancer, it's working with passing Solana account data. Bro, I'm not even gonna think about all of that right now. So just salute to you too, bro. Yeah, yeah. So let's try the test for this. Let's try the test for it, right? My PC lagging. Yeah, we're 2 hours down, we're going 5 hours. It's piece of cake. I hope I don't die along the way though. Let me get water. I'll live, I'll survive. I'll survive. Yeah, let's see. Write the test. People have done more than 5 hours. When you're writing your program also, you sit down and write code for like 5 hours now, but now it's doing it live in front of the camera. Let's create a test folder inside our source. Let's do the test at the source. Because why not? Tests. Bring this out to source. Then in my librs, okay, let me put a mod rs here. You see a module, mod rs. So now in our librs, for us to include the test, we need to include the test here, mod tests. That's all. So I'm going to be writing our test with light SVM. Let's write down our test with light SVM. And I'll just throw in a bit of boilerplate code, or I'll explain along the road. But I had installed all of those things already in our. You check the cargo with Toml, you see what we are using. We're using Pinocchio. I using Pinocchio system. Am I using Pinocchio system anywhere yet? Not yet. Am I? Oh no. We're using Pinocchio token. We will, okay, not yet, but we will because we will move tokens. Then Pinocchio pub key, Pinocchio log for debugging, then remove the log when I'm pushing. Reset an account, byte mock. So for development, we're using latest VM 0.6. Lot of old versions, bro. Don't shout at me. I know what I'm using. I know I should be using 0.8, but no, I'm using 0.6. Leave me alone. All right. So Solana instruction, Solana key pair, native token, Solana pub key, Solana signer. All of this, I'm using all of this independently because for this 0.6.1, there were still a lot of things figuring out there. So if you just use Solana program, let's say for example, get all of this from Solana program, the types will not be compatible with the types that Light SVM is expecting. So we needed to import these guys individually. But I think from this version 8, 0.8, 0.8, you do not need to import these guys individually again and just use Solana program on or wherever is used. Solana, yes, Solana program has all of this inside of it. I use Solana program as Solana token for that part. It could. But for now, we're on 0.6. I'll stop with that. Let's use that. So in our test, we want to write. How do you know that it's a test file, right? So just write pub test test. And you specify that this is a test. Let me just pour in the boilerplate code, bro. Let me bore you with it. So this is the Pinocchio one. Is this the Pinocchio one? No, this is the Anchor one. I add it. Okay, yeah. This is the Pinocchio one. Oh, yeah. So let me search for fundraiser. I think that fundraiser had a lot of examples. Inspiration fundraiser. Is there a fundraiser here? There should be fundraiser. Raise some funds, bro. Yeah, there's a fundraiser here. Open the repository portal. So source, then tests, then mod, then bro. Are you waiting for me to click on that button? Waiting for me to click on the button before. Yeah, so you put this config test on it, then I did not use this random number anywhere. I just imported it. All right, copy. Let me just copy the whole imports, and I also need to do the do I. Okay, let's assume. Let's assume I need to do that. But let's see. Let's see first. Let's just pour it in. We so if you guys want to be backstage, right? Just drop it. You can check the comments or just drop it. Drop it what's about drop a comment that I want to be backstage. I should bring you backstage. So I will send you the link and you can be backstage here. So you can just chat along the way when we get to the breakout for chats, right? So yeah, config, close this bracket. So one thing you want to know is okay, when we start writing first. We'll start writing first. So using instruction, then initialize, use create instructions, then is it's initialize, what do I call it here? In initialize, I needed this initialize switched. That was what I needed there. Initialize switched. Yeah, I think what was instruction. Instruction. Yeah. And I need this random generator. I don't know if it anywhere, just something like that. So I need to allow unused here. There's a lot of unused things currently. Unused, not uncommon. Unused. Yeah, thank you very much. Then what else? What else? What else? What else? All right, so this is probably everything I need for now. I imported light SVM instance, the instance of so the light SVM is SVM Solana virtual machine. So a light Solana virtual machine, just like a soda, like a soda drink. So it is a fast. You can just read it off here, right? A fast and lightweight library for testing Solana program. It works by creating. So this is for our unit test, right? If you want to do unit testing right now, if you want to use Solana, want to use Light SVM. After using Solana, after using Light SVM for unit test, to make sure everything works the way it should be, we'll now move to use normal Solana program, whatever we use for writing, making, and deploying to maybe DevNet or something. Yeah, slide them the fast and active library for testing, blah 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 blah. Yeah. That's basically like that's basically all for that part. Yeah. So what I'm doing here, the program ID is create ID. This is a pub key. This is a pub key already. Why do I need to use? Why do I need to specify as a pub key? I'm not touching it. It works already. So, yeah. So let's get started with first thing. Okay, there will be a problem along the way. So to avoid that problem right off right now, I want to create a reusable state. I like to call it reusable states. It's not states, it's basically accounts. So let me just call it reusable. And it might not be all accounts, reusable states. Top structs, reusable. So I want to say every every test you write is an isolated island. It's an island. So they cannot compete with each other. There needs to be a way to make this test communicate with each other. So if I have a global state inside the test, if I use this here, I've created the account, I save it in the struct, I can reuse that struct in the next account, right? That's basically what this reusable state is for. So for my tests, let me show you what I mean by that. Where is my reusable state? Yeah, reusable state. Yeah, reusable state. Did I move it? Did I move it somewhere? This is me using the reusable state here, right? But I think it should be under the program, probably. Reusable state 9 times. So the first one, reusable state, second one, reusable states, reusable states, reusable states. I think yeah, this is it. I don't think I need all of that though. But let's see. Let's assume I need all of that. So the mint. So now I'm not using make ITA. It's called streamer ITA, right? Let's assume this is streamer ITA. Streamer ITA vault. Is it vault? It's called platform treasury. It's called treasury. ATA. Yes, ATA program ID. Token program ID. Token program ID. System program ID. Fundraiser, no, that's a streamer state. Streamer state. Maker is the signer. Signer user, it's optional. I kept that optional for a reason. I think this should be all that we need for now. Signer is the keeper, mint the key, treasury is this. Or I'm just trying to think of things that might reuse data, but we get there. The next one, let's do. I want to create the first instance of this program. The first thing, if you're writing Pinocchio test, if you're writing anchor test with Coral. If you are using as a jest or whatever testing framework you are using, there's this setup that we do before. So like before, you can put in a before block. So that runs before every other thing in your test. So that's what this setup is also doing. You get, so let's copy the setup function. Yeah, I don't need everything inside it. I'll probably remove everything inside of it soon. Soon. Copy this and bring it here. 1 minute, 1 minute. And I'll remove everything inside of it because I don't need everything inside of it for now. I did everything inside of it. Regardless. I do not need all of this. For now, I will when I get it. Okay. So now what is the setup? Setup is, like I said, your first instance, your first entry point, not entry point, the first block of code that you want to run before before you get into your other test. So what are we doing here? We're creating an SVM instance, light SVM new. We're creating a new pair to deploy the program. Then, oh, then by airdropping to the user. So that's svm.airdrop. Do I have my SVM pair something? So airdrop pub key, and how much 10 sol, airdrop 10 sol to the person. With this is inside light SVM, not testnet or mainnet or devnet. This is a separate virtual machine, a lightweight virtual machine. All the tokens you have here is not on testnet, not on local net, not on mainnet, not on devnet, it's on light SVM. So I want to load the program SO file, the binary file. After I've built it, so it is called in target. It's being target, then deploy. Okay, I've not built it. This is the key pair. This is the key pair. So I need to get the address of this key pair first. 1 minute. So I can do Solana address. And how did I get this key pair? You might ask. How did I get this key pair? It's just simple. What I did there was I'm just write it again. Solana keygen. Right. Keygen. Let me grind it this time. Let me grind it. Solana keygen. Grind hyphen starts. Let me just hyphen help. I want to get a specific key. That's why I'm grinding. So I think it starts with, let me say it starts with sol or starts with MYT. Let me use that. So now keygen grind starts with MYT. I need just one account. That is correct, right? Starts with, not starts with. Let's go MYT. Then I need it to be silent. Then the output file should be targets deploy or switched underscore program hyphen keeper.json. So switched program hyphen keeper.json. There should be a hyphen first, the hyphen f. Let me do hyphen f to overwrite what's there currently. And okay. Silent does not work on grind. Silent works on new. If I wanted to do keygen new instead of Solana keygen grind, I would have done Solana keygen new. So I think. All right, let me go to help again. I'm mixing the commands for new and Let me just use new instead. I'll grind data. Let me grind now. Grind data. Ha ha ha. So let me use new. Let me just new. Don't let me grind. Let me just use Solana key then new. So I want it to be silent and I want the output file to be this. And if there's something there before, override it. That's what I have this F for. Yes. So for the security, blah 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 blah. No. So I wrote a new key pair to switch underscore program. I think keeper that this. It has created a new key pair now. So I have a new key pair here. Right. If I want to change the name, let me just change the name so you see what that is. Sweet underscore program. So you see, it created this sweet underscore program. Yeah. So that's what it does. Delete this. So what this line of code is doing is anarchy and new. I want it to be silent. If I don't put it silent, it will pull out the private key in the terminal. We don't want to do that live, right? Then the output file is target deploys and the name of the wherever I want to do it. So that's basically what I did there. So already we've done that. Right. So let me put that here. Let me see. Solana address. Solana address. The path to the key pair is target, target, deploy, then switched, I think, yeah. So this is the program ID now. I want to copy this program ID, then inside my librs and that program ID, yeah. Yep, that's basically what that is. So now I need to tell you guys, let me tell you something. Let me tell you something. First, let me comment this guy out first. So it will build successfully. To build a Pinocchio program, you just do, uh, I think, cargo, forgotten, cargo build, SBF. Yeah, I remember. SBF. Yeah. So now, deploy cargo build. Then let me do cargo test. Cargo test. That's the test, by the way. Let's see. Just wait for it. I hope I don't clock my CPU. And almost there. Yeah, I think I just freeze. So it's not frozen. Yeah. Well. Okay, so do I have a deploy? Do I have an SO file in my deploy now? I still don't have an SO file. How do I do? I think build SBF. Oh, in my cargo tunnel, I need to specify that I need it to be 1 minute. Let me check my cargo tunnel from this guy. Source for source cargo tunnel. Let me check my readme. Is there a readme and the rest of the file? If you make it up on this, okay, I did not even put how to do this. Yeah, yeah. 1 minute. Cargo terminal. Is there? Yes, I think I need to put this first. Is that the problem? Is that the problem? I think. Who knows? I think I need to do that. Hmm. Let me see. Let's see. Let's see. Let's see. So cargo build SPS. Let's do it one more time. Yes. Now I have an SO file. I needed to include this. That was why I now have an SO file. Now I have an SO file in this switched program SO. In our test, now we can uncomment all of this control uncomment this. Now let's get to sounds. Let's get to not Pinocchio fundraising. There's no Pinocchio fundraising. There should be deploy. Yeah, free program F4. Yeah, no errors. So program ID. Cannot find program ID in this book. Do I need to do? I only have program ID. But I think I did not. Program ID is this. So I should have done program underscore ID is a function. Out is a function. Fn program ID. It just returns a pub key. And I'll do pub key. Just copy it, bro. My bad. Then I'll do where is it? Just that's what I have to do. Imagine. Just do this. I don't want to rewrite it because if I wrote it there, I might need it somewhere else that I'm declaring them as program ID. So I'll not start rewriting it. And now we have. So what we're doing here is getting the bytes, the link to this SO file. So that's the link to the program binary. Then adding the binary here, then specifying the program ID. So if I wanted to create, the interesting thing about this is I could get the binary of, let's say, DAM V2 or whatever program on chain, and just load the SO file here. I'll not even do the SO file. I'll fetch the SO file from maybe DevNet or mainnet or wherever the account is. I'll just fetch that one, and it will. I can already interact with DAM V2 in my light SVM instance. Cool. But let's keep going. So we've loaded the program into our light SVM here. Then we want to do, next thing we did was creating a mint, new mint, create the payer of the mint, this payer that we had dropped some tokens to. Authority is the authority, send unwrap, please unwrap in production. What the fuck? Please unwrap in production. Sorry. That was AWS nightmare now, unwrap. Then we need an ATA for that guy. So let's call this ATA. What do we call it in our streamer ATA? Streamer ATA. For us to have a streamer ATA. Okay. For now, this is not a streamer ATA. This is we need the. This should be called the treasury. Where is it at? The treasury. Yeah, treasury is an ATA. So this should be called the treasury. Yeah, that's the treasury. We're creating a Shita token account from Pinocchio. From sorry, Light SVM token. Why is Light SVM token? So creating a Shita token account from Light SVM, and when you do that, you will pass in the Light SVM instance, the payer, and the mint. So we have a mint, newly created mint. We have this guy, and we have that guy. Now we already have a treasury account. Now we need to derive. So this one is called, do we even need this initially? I think later in the future we will need it. So this is called the streamer state. No, we need, firstly we need the fundraiser state. Not fundraiser. It's called global state. Yes. So we need global state to be a pub key. Yeah. Let's do global state also. Global state is a pub key. So when you do find program addressing, you are getting the pub key and the bump, right? So that's why I'm saving the pub key and the bump, basically. So when we do fundraiser, so this will be called streamer global states, right? Global global states, global states, yeah, global states. Then ATA program ID. Our token program. Where is associated token program? Where does that come from? I will get that in a minute. Associated token program ID. This is associated token program ID, bro. So I can use the token program ID. That would be an error. So it should be pub key from, yeah. So let me do it this way. Just do it this way. I created this where is it? Where is it? Token program. Where's token program? F. Yo, this was right in front of me. Yeah, this one. And make that right on top here. Associated, not associated. Associated token program. This was the associated token program. Right there. So token program. Token program ID is now token program. And system program ID is now system program. And yeah, so vault, we don't have a vault anymore. What we do have though is the treasury. So we represented vault with treasury. Yes. Treasury, yes, treasury. Do we have it? Yeah, treasury. Then the maker is payer. So we don't have a pay maker anymore. We have, what do we have here? Signer. That should be admin actually. It should be admin. Admin is payer, yeah. Then a payer here. Yes, so here should be admin. That's the admin payer. Then maker IT, or else maker IT. Treasury. We have, let me see, let me just leave. Let me remove this if it will be an error. Well, no error. Oh, there's an error. Streamer ATA and streamer ATA and streamer state. Streamer ATA and streamer state. So let's get streamer ATA. Streamer ATA is from the user, then key. Let's check. Libres, initialize. So I've not even gotten to streamer ATA yet. So for now, let's remove those streamer ATA and streamer states. For now, streamer states get some rest. Streamer ATA, where you at, you need to also get some rest. Let me remove those two. Yeah. Now we have a reusable states that we can throw around. So our global state is from the global states. Make a mistake. Global state is from initialize. Global state is from the keys of global states and the program ID. So just global states mod test areas. So global states, that's all. So we're good. I think all systems are good. Yeah. So now we have a reasonable state that we can use that replace. So now let's create our first test. Create global state. Global states, then returns nothing. So now let's get started with. So we want to use most of these reasonable states. So if you want to write when you are communicating with your anchor program, when I say an anchor program, your Pinocchio program, like I said, everything is basically accounts, instruction data, and the program ID. That's basically what it is. So it will look something like this when we are done. Let me just get that from here. When we are done, it will look something like this. Yep, should look something like this. So this is the end. They need to justify the mess. So in its instruction is an instruction. Instruction is from Pinocchio instruction, Solana instruction rather. So the program ID is our program ID. So let's get to our instruction here. In the initialize instruction, what are the accounts that we need? In the initialize instruction, we need the signer, global state, token account, token mint. So first thing, we need the signer, global states. Let's get those from setup. Let's equals setup. SVM and reusable states. It's called the reusable states. Aha. So now let's get what we, only what we need from reusable states, right? So let's first thing reusable state is let's token mint. So I'm looking for mint. I'll be let's call it mint. Mint. Let mint equals reusable state dot mint. What else? Let's pair. Let's pair equals pair reusable states that's admin. Is admin a keeper to be an address? Yep, cool. So the next one is managing fundraiser. So signer, oh, how about then treasury? Let's treasury. How am I putting in treasury? Treasury ATA should be treasury ATA because reusable state the treasury. We have that. So we need how many accounts here? 1, 2, 3, 4, 5, 6, 7, 8 accounts. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 accounts. So we need rent silver, we need rent. Then okay, let's do let me start from the top. So let's associated token accounts. ATA ID, bro. ATA ID. Reusable states dot associated token accounts. Reusable states dot ATA program ID. Good, very good. So this one will be ATA ID. After okay, token program will come before that one. So let's token program equals reusable state dot token program ID. So that will be token program ATID parentheses var token program ATID, then system program equal with that. Let system program was reusable states dot system program ID. Let's not letter. So we have 1, 2, 3 system program, then token mint should come after system program, token mint, then token account should be treasury ATA, so should be treasury ATA. And by the way, these are accounts. So these ones are just read only. It's not read only accounts, right? So it's an account, a writable account. These are writable accounts, but they are not signers. So not signer, not a signer. So we check account meta new. It says is it a signer? Is it writable? So if I do new on it, new is asking me what's the public key of the account and if the account is signer. So account meta new, the pub key is this. It's writable. If I want a read-only account, I'll just do read-only, right? It's not writable. Read-only account. And I'm saying it's not signable. It's not a signer in this case. We don't have a signer. It's not signer account here. But this one is a signer. The payer is a signer. So we have true here. That's what we have true there. Yes, that rent silver check. Token program check. Consider token program check. System program ID check. Token mint check. Global state token account check as treasury accounts, then global state. So that should be let global states equals reusable states dot global states. So that should be global state position 0 and signer all good. So these are all the accounts that we need to communicate with this instruction in the accounts here. So don't forget if I go to Liberes, you can see what an instruction basically need is the program ID of the instruction I'm communicating with, all the account they are passing, and the instruction data. So now we have the program ID that I'm communicating with the accounts, and now the instruction data. So how do we get the instruction data? Instruction data should be the discriminator first, then the other data I want to pass to the account. So the discriminator first, and other data that I want to pass to the account. So that would be an array, right? So that would look something like this. But because we already have. Oh yeah, that's it. Let's sorry, ix data equals an array of. So the first thing that will be in the array is discriminator, right? So now, what discriminator do we want to use? We want to use the create instruction, the create global states. So that is this one that I imported up here. Let me close this. Put the size of that. That is initialize switched, this one. Because that's what is here in the process initialize. You see the initialize switched. Oh, sorry. This is the instruction handler. What I need is the instruction discriminator, and that is from. Now I go to yeah. So initialize. So that should come from instruction initialize. So instruction initialize. In this instruction, switched instruction initialize. That's what I need. So I need instructions, switched instruction, and initialize. Where is so from instruction I need switched instruction. Yep. So yeah, we have to pass in the discriminator first. That's switch instruction initialize. Yep, that's 0, an array. So then also now important thing is we already know how to deserialize our data, right? We have a 2 bytes there. So we can do let's data ix data, let's call it instruction data, because we want to pass in the fee in basis point, fee bps. That's how I'm doing this. We want to pass in the fee data, data, fuck, data. Social data is now, it is switched instruction, which initialize switched, right? And it's just, but oh sorry, I got this guy is fee bps. Now whatever fee we want to use, let's say we want to use a 2.5% fee. Let's say just 1% of it. 1%. That's 100. So once 1% of the transaction fee, right? So that's be 100, right? So we can pass here is ix data, because we already implemented it to bytes on that, so we can just call it to bytes and to convert this guy to bytes. So yeah, write that to bytes. Okay, I need to convert this. Yeah, let me just, this is what it looks like, but I need one more step. Let's see. Yeah, I need to change this into a vector first before I use that one. And why it's a vector. So as u8, can I do, is there 2 early bytes on it? No, no. So I need to put it into a vector here first. Vec. How am I seeing one? Oh, yes, one. As u8, it's already u8, right? U8. So can I do dot to early bytes on top of it as early bytes? I could if I switched it, but no worries. Then if I do this, I think we should be good to go. So what did I do here? I did instruction as u8, then this one also as u8. So now what we need to do is, now we have a 2-dimensional array. One array here, another array here, one array here, a vec of u8, another array here. So I need to make all of them into a single array. So I can do dot concat on that, right? As an instruction is just expecting an array of bytes. You can read the array of bytes, one single array of bytes, not an array of byte of 2, blah blah. You just want one array of bytes. I can concatenate that into one single vec8, one single bytes. So that's what I will pass here. So I will now have my ix data. Yeah, so that should not make any noise. Yep, we are good to go. So we have basically constructed the instruction that we want to use. So what I want to do is just send it over. We could use a message, get resend block hash, build it from that, or we can just send it directly without creating a message word if it first. But since this example is using a message, let's use message also. I'm not a fan of creating a message before sending the instruction, but yeah. Who asked for my opinion? Nobody. Message is message new in its instruction. Then who is paying for this instruction is optional. So you put a sum and the payer for P. A recent block hash. So I have a transaction new. Basically, I'll just do a transaction new and send the transaction without passing the message or whatever. So we have transaction new. Then, so if this is a if the multi-sig, you put all the signers there, but I'm using just one signer. So one keeper, then the message we are sending, we are building transaction for, and we send block hash for that transaction, and we'll just do an SVM into immutable. You do svm.send transaction, and that's all. That's basically all. So I need to do. I want to log out because I like benchmarking, right? I want to log out the instruction C's. So I just copy this one. I'm going to copy the log. In case if the instruction field, I want to know why it failed. And if there are any logs inside of it, I want to know. What did I just copy? I need to copy this one, this one. Yeah. So this one should return a unit type. Basically, it shouldn't infer that already. It should infer that already. So it should return a result of okay and whatever error type that is. Let me check. It should infer that already. Let's see. Result okay and error. It's close enough. We're live. Let's make this test, which should fail, because why will it not fail? Like, whose land will the test not fail on the first try? So let's do a cargo. Let me make sure I'm not running other multiple things that can cause this thing to crash my CPU some way. I'm on a 12 gig RAM PC. I need to upgrade that. But for the purpose of this tutorial, let's assume we can't upgrade it. Yeah, so let's get back to that. Let me close something that are not important. So now let me check my system info. System monitor. And I'm running, yeah, I'm on 74%. Yeah, we're good. We're good. Probably. So let me do cargo build SBF. I always forget that stuff. Build SBF. And after I've built, I want to do a cargo run hyphen hyphen cargo test, not run. Cargo test hyphen hyphen no capture. So this no capture will allow you read out all your logs, allow you spell your logs into the console. Let's go. Let's see. We're building now. Sorry, no. So we know I think capture, right? So we know capture as well as in JavaScript land. Well, that correct. Wow, that worked without without any errors. That's crazy. But I need to validate that what I did actually went through, right? That's crazy actually. First time I run a program without having any error. Am I sure this program did what I actually wanted it to do? Yeah, I can check to see. So we have this tx.complete unit consumed. So it consumes 3,105 CUs. That is way less than what Anchor would consume. I can optimize that. I can still optimize it. How would I optimize it? Let's see. Okay, let me run the program again. Let's run it again. Let's make sure we have consistent value. 3105 again. One again. 3105 again. So let me show you what would happen if I did not use rent. If I use rent get, so you should have an extra maybe 3205. Let me use rent get here in initialize. Let me use rent get, not rent from account info. Yeah. Let rent state because rent get call the function that yeah, just do rent get. Yeah, and I can now do rent state dot minimum balance. So let me comment this one out. Yeah, let's do rent get, then build again. Let's see, so 3105 previously, right? Let's see how many CUs is now. So we have 3217. So this gets, yeah, consumed 100 and it was 3105. So it consumed, I think, 132. Let me just do node 3217 minus 3105. 111, 112 extra CUs of what this rent of get did for us. So let's remove that. Let's see what else can we remove? What else can we remove? What can we remove? If I know what is byte more, if I wanted to use this to have reduced the CUs. But yeah. I think we're good. Yeah, that's all. Close, brother. So let me run this again. Let me save this. Am I running nodes? Not running nodes. I'm running this. No capture. So we should be back to 3105. Yeah, back to 3105. See, yes. Good. Yeah. So what else? So I want to validate that what I sent in was actually correct, right? So let's, in our test, we can fetch an account back from SVM from our initial SVM. Since we've created the account inside the program, we can fetch the account from SVM. Do I remember how to do that? Let me check. Moderate, yes, I'm the right place. Move, bro, scroll. Then contribute. I want to. Don't tell me I'm not doing that. I should be. I want to. Oh, I'm doing it inside my test down there. Is that a font? Not this one. Yes, this one. Yes, this one. A minute. A minute. A minute. Yeah, I think. Yes, it's this one. SVM does get accounts, then the accounts, and do whatever I want to do with the accounts. I think this one. Yeah, this one. Yeah. So let me check. So let's make sure what we sent is actually what we wanted to send. So let's we called it um, global state global state from SVM because SVM will get info, then we are getting state dot global. What state? Should not be state. Is there a state here? Where is this state from? State. Yes, reasonable states. Why I call it state? Reusable states dot global state. So if I have this account, it's now an account. I need to cast that account into a global state account, right? So I can use Bytemap, yes. Let's pass account equals Bytemap, then from bytes. Is it from bytes? This is an account. Like I can convert this account into bytes. From bytes, and I need to pass what kind of account I'm looking for. I'm looking for a global state account. Sorry, global global state account like that. I need to pass the byte of this. So let's do global state. What's wrong with you, bro? Yeah, global state from SVM and do it 2 bytes. Dot okay. Dot data. Dot data. Blah, 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 blah. I think there's this dot data. Let me use dot data. It gives me a vec. Dot data. There should be error somewhere. Data is a vec. So now let me log out. Let me print line. Print line. Here is the data on chain. Uh, uh, question mark. Then let me log that one out. First account dot. So let's see the admin. Who's the admin user now? Let's get. We should have an admin, but this is a pub. This is not a pub key. So let me do. Okay. I can just log it out like that. Let me just log out pass data because it implements debug. I think it implements debug. I can just do test again. Let's make sure we have something. Yeah, so now we have data inside the account, actual data. So the bump is 255, initialize is true, the admin is this guy, plus 150. So our program worked well, that's crazy. I will not have any error starting. But we can pass it into meaningful information like a pub key into a normal pub key. We need to now verify. We can verify that past account dot okay. Let me do this also. Let me assert. Let me make one assertion. Assert. Assert. Pub key. I can do pub key. Pub key equals yes. I've done before. So the pub key one is global states dot not global states reusable states okay, I have it here already. Let's see, what do we store? We store the treasury ATA, right? So let's do treasury ATA. I want to be sure that treasury ATA is equal to passed account dot the platform fee account. Yes, platform fee account. Else shout and tell us, bro, the accounts are not the same. Similar. Okay. Okay, I need to borrow here also. I think. Yeah, and I'm already having a borrow. Expected reference is found reference pub key. I need to convert this into bytes. Which one is the first one? Expected this. I have this treasury ATA dot 2 bytes. Thank you very much. Yeah, we're good. So if I log this now, let's run this again. If there's no error, yeah. So cool. It's telling us that the treasury ATA that we passed from the client was the same as the past treasury ATA. Yeah, so that's cool. That's good. That's what we're looking for, right? And yeah, that's good. That's good. So now let's go. We have this. Let me make a push to GitHub. So let me see my git ignore. Hope I'm ignoring the down left already. Okay, target. I'm ignoring everything target. So let's do git add this. It's commit. Implemented. What do we implement? Sir? We implemented create account, create global state and tested. Git push, git push, git And still loading. Yeah, and we have it now. Let me check that repository is correct. Open on GitHub. Open on GitHub. Where's my GitHub? This one. Why is it in GitHub? Yes, good at them. Okay. Open. Just take your time. Don't take your time. I don't have all day. Uh, Why is it taking forever to load GitHub? Why is it taking like 1 million years to load GitHub? I basically don't understand why it's doing that. But let's see. I have github.com, github.com. It's the right, yes, this one should work. Uh, rather. So the last push was, I think, 1 minute ago. Yeah. We have commits. This is the commits. Let me get to the commits. This commits, we added this name, then we introduced this, and we added the test. Yeah, so that's good. So we want to take a break to discuss the what has been going on so far before we get back to coding. So let's see. Daniel left the chat. If you like to be backstage, just shout out. Yeah. Let me ping Daniel back. He left the backstage. Let me bring him back. Let me bring him backstage. Let me bring him backstage again. So anybody that would like to be backstage also and just chat. Let's chat. Yeah. Uh, yeah. My internet is messing up. Now I know why it was taking forever to load. Am I still live though? Am I still live? Though? Yeah, Dan is coming back. He'll be back in a minute. Let's just about state of Anchor, state of Pinocchio. If you guys have any questions, just drop the questions in the chat and let's talk. Let's talk. Let's talk. And if you're enjoying this so far, I am enjoying it. I am actually. It's like a marathon. 3 hours down, 2 hours to go. Bread is not melting yet. Is that okay? Still coming in. Yeah, if you like to be back, so you guys just drop a chat, drop a comment. I will bring you up. Let me even look for people that can bring up stage. Let me see. Emmanuel should be here. Ryan should be here. Let me share the link to this repository. I think I said it. There's the link to the Pinocchio repository. Put it on in the chat. So far so good. We've done and we've tested the initialize. So the next thing logically would be create a streamer. Then we can now move on to other transaction. I knew I was not going to finish this thing in 5 hours. I was messing around too much. Yeah. Where is Daniel? That has end my message. Let's see. I'm messaging again. Let's find that. So the next instruction is basically the remedy. We've done global state. The next one should be create streamer. It actually takes longer writing Pinocchio programs, but it's rewarding. It's rewarding overall. If you think about it. Yeah, Daniel is back in the stream. Alright, so let's move this over here. Move this over here so we can talk everything. Yeah, go find that. Yeah, Dan. So guys, meet Dan. Dan is Alpha R on Twitter. Is the founder of Rust Undead. In case you don't know, let me put it on. Rust Undead. Rust Undead. Let me share. Yes, this is the Rust Undead. 1 minute. Bring this up. Yes, this is what I was looking for. In case you don't know, Rust Undead just did a partnership with Solana Foundation, like with internet. Don't mess with me now. Yeah, my internet is crappy, like freaking crappy. It's taking forever to load an image, a single image, bro. Let me just show you. Let me show you from here. So Rust.net is an education app. Okay, Daniel, just do the intro. What Rust.net is. So we'll get started.
Yeah, Jim, guys, can you guys hear me?
Yeah.
Okay, so nice to be here. I joined like when we started, but I had some work to take care of. So yeah, my name is Daniel, Alpha R on X. So I'm building Rust on Dead, which is the gamified way of learning Solana. So if you want to learn Solana, master some concepts like Pinocchio, like what inspiration was doing today, you basically do that in a gamified way via Rust on Dead. So right now you can battle on the player versus player mode with your friend and opponents. We're working on the single mode as well as other things, and yeah, we basically have like some support from the foundation. We have Solana Foundation supporting us. We have
You cannot say it that way. You cannot say it basically, bro. This is not basic. This is massive. Yeah, come again. Take that line again.
Yeah, so I think using basically is part of my, like, the set of words that I use. So it is not basic, you
Okay.
know. So we have foundation supporting, Solana foundation supporting, which is actually massive, considering the fact that these holdings started 6 months ago via like kind of a chat with Jonas, and we're not perfect. We're far from perfect. Like I think the game is actually it is taking you know, more than like it's kind of like, okay, I thought this was going to be like very easy to build, but it's not, considering when you have to do a couple of things, have to build interface with a couple of things, and we're actually moving towards mainnet, which should be Q1 2026, most likely January thereabout. And then we're going to have like change of flow, change of UI, change of a lot of things, so just to make it very easy. So we also have like support from Metaplex, which is not basic again, it's actually very, very massive. We've had Turbine supporting us from day one. We have we have a lot of supporters. We have Super Team also, you know. So yeah, happy to be here. Thank you for having me, Inspiration. I actually really loved what you were doing. Just that I wish I could stay like from beginning to the end, but I always have to like jump off and then come back
Yeah,
on. So
yeah,
yeah.
cool. Yeah, cool, man. This is massive. This is so it's like a dream come true for you, right? Like, oh, did you imagine you'd be here?
I mean, not the ideal product
Okay.
that you would dream of. It's not like you would dream of Magic Block, or you would dream of like Magic Eden, or or you dream of something like big infra wise like Jupe. So it's more of like and this desire to do something that would help people, right? So I know that there are a lot of documentations out there, and a lot of people have to like go to like some things, and have to like try to memorize and try to understand. You were mentioning something about zero copy,
Yeah.
and you mentioned something about how you work with Pinocchio and you work with bytes. You know, things like this is sometimes you need a little more effort to understand how these things work. So that's what we want to do with us. And then it's not ideally the dream products. I wouldn't even advise anyone to found anything right now. If you're good enough, like Inspiration, just go apply for a job. Just go apply for a job. Don't found anything, because you basically have like headache. You have like headache, a lot of headache and a lot of work. But it's actually nice building something to help people.
Yeah, cool. Cool. Yeah, so let's do a little bit of Anchor Pinocchio banter, not like banter. So, what do you feel the the major win is for currently with Anchor? What's the major win currently?
Network was actually very terrible.
Yeah, sure, no problem. Everybody's in Nigeria. So, what do you think the major win is for Anchor? Like now, what has Anchor been able to do that I think is a very good thing that Pinocchio doesn't have currently? What do you think? What do you think?
So I think from chat, like some conversations I've seen with Jacob and some guys. So having Pinocchio um inside Anchor, embedded, meaning that a lot of things have to change. So when it comes to deserialization, you have to basically go with zero copy deserialization and serialization, and I think that's going to be massive. But then some people would have to like navigate the space of how they treat data in Anchor. So you know that when you work with Anchor, you have this flexibility to deal with a lot of data types. You can deal with
Mhm.
strings, which is like, strings are okay, but they have some limits. You can deal with bytes as much as you want, and many more. But you know that with zero copy, you have to be very careful how you deal with some data types. So it is I think we need to be ready when that time comes to enlighten people on how to navigate across unique data types that are no longer like compatible with Anchor. So win. I think win. When I say win, I think Anchor is very important for building both performance programs as well as security tight and easy to use programs. Like you can build programs easily with Anchor. I guess the improvements will be on the size, the compute units consumed, and a lot of redundant things. So yeah. I mean, 2026 is very bright for Anchor.
Yeah, cool, cool. So, how do you think a beginner, let's say someone that knows a fair amount of TypeScript, someone that is a dev already and is just in dev, Anchor or Pinocchio, and why?
Well, the truth is that if you're building with Pinocchio, you're actually writing native Rust. So if you're good with native Rust, you are good to go. But I would always say Anchor. Anchor is the best to go with for both a newbie and for both like a well seasoned developer. Like even if you're building like production based programs, use Anchor. Why? Like apart from the short falls, like the size things and computing stuff and like the bloat and stuff you have, I think Anchor is pretty much going to help you to avoid some certain things due to let's say um, constraints that are not handled with native Rust. Native Rust you have to build from scratch, low level, and while you can do a lot of things easily, with Anchor, you still have some overhead. So I think if we have those overhead covered, like where you have like some things removed and Pinocchio is inside Anchor, Anchor remains the best. So it's not Pinocchio versus Anchor conversation. It's more of like uh, so we can say Pinocchio versus Solana program. Which one would you want to use in native programs, right? So
Okay.
are you going to use the Pinocchio library, or is it going to be like Sona program library? Which Pinocchio is the best? So hopefully we see
Yeah.
Pinocchio in Anchor, so we just get all the benefits from Pinocchio.
All right. Well, can you still spare 5 minutes, or
Yeah, yeah, yeah,
do you
yeah.
have to go now?
Let's go. No, no, no. Yeah, I still have like 15.
Okay, okay. So let's
Mm.
say you want to build an AMM. You're a good dev. You're a good dev. Anchor or Pinocchio, and why?
So if you're going to handle people's money, I think you have to be very careful how you handle numbers. So like AMM, it's basically people's money. How do you handle your swaps? What's your formula? What's your So there are technical things I know that they're very important. I don't know any of them, but I know that some things are important in building things like that. So Pinocchio, yes, if you want to have a very efficient program, that would basically give you what will I call it? So if you use Pinocchio, you have some certain benefits like comes with it, right? And then you can actually use it in AM, like when building things like that, trading features that you need some tight constraints. But I still take Anchor because Anchor makes it easy. I mean, it makes it very easy for you to build things like that. But then you have to be very careful, so you don't have some bloats here and there.
Yeah, okay, okay. I agree. Using Anchor is easy. Is easy, but the main why the reason why you want to use Pinocchio for an AMM is basically, how am I saying basically? So number one, apart from security, you have to be responsible for the security of the contract. You can still write Anchor and write insecure contract. That's very possible. Like it's very possible. It just comes to the experience of the developer. You can write Anchor and write very vulnerable contracts. That's a thing. But it is Anchor has made it easier. If you're writing something like that in Pinocchio, one, it will be cheaper for your users. the users will not spend more gas doing a swap. So let's say they are supposed to spend, they might spend like maybe 20 or 30% amount lesser, or 40%, depends on how optimized the program is. If you're writing something big and you want to, you have an anchor program, an AMM in anchor that consumes, let's say, 20,000 CUs to make a swap. If you do that same thing in Pinocchio and you'll be using like 10,000 or 7,000 or 12,000 CUs in Pinocchio, do you think it's worth the hassle writing this in Pinocchio?
And we
That's like
is it
half. That's like already half.
Yeah, can we enlighten the audience like what are the benefits of having lesser CU? Like from
Okay.
your own point, yeah.
All right. So right, having lesser CUs would mean you are using less compute power on Solana. That means you are paying less gas fee for that transaction. So if you for a transaction that you pay gas fee of, let's say you pay a gas fee of, let's say, $0.5, and using Pinocchio you use 0.025 or 0.25 in that sense. So do you think it's a reasonable gain for the developers headache or and for the users headache? Because in that sense, do you think it's a reasonable gain? That's just half, $0.5, half of $0.5, 0.25. Is it a reasonable gain?
Yeah, I mean if you compound it, right, I
Yes.
guess you can spell like you can spell some bucks when you compound it. But how sure are we can get the security, the complete security that Anchor offers in a way in Pinocchio?
Okay, let me show you. Let me show you this. There's something from um Anchor Docs. If you check Anchor Docs, Anchor Lang, they show you how you can write very inefficient programs with Anchor. So if you do not know, as a new developer, I just come in to write Anchor. You might just write Anchor the way it is, but because of the docs they've done, let me see, where's the example? Is there an example? Uh, I think, let me see, the basic structure type. There should be an example on, okay, let me see, Anchor Lang example, examples. There's a part of the repository that has how you would do this and how, if you do it this way, it will be yeah, you'll be introducing some bugs. I don't know if I can find that immediately, but if someone can help me look for it in the chat. They show you three ways of writing program: a secure one, a fair one, and a very vulnerable one. So there's, you can see, right, it's very possible to write insecure programs in Anchor if you don't know how to use the constraints well. You don't know how to say, okay, when I'm writing, let me show you an example of this one I did here, this Anchor program that we're porting. So now there's a place I did a lot of constraints for an account in, I think it's not in the it's in the withdraw. It's in the withdraw. Maybe withdraw admin. It's not this one, but let me see. Okay, yeah. Let's just assume this one now. You have a treasury account. You are setting that is mutable. That means anybody can, that you can remove balance from it, right? So, and I'm also making sure that the amount, the mint that are passing is the mint that I expect. The authority is the global state. The token program is the actual token program. And I'm making a lot of constraint checks here. But if it's not an experienced anchor dev, the person will just write mutable. They might not even know that this associated token means associated token authority exists. They just write mutable, and an exploiter can just exploit their program because they don't know. So you can still write inefficient Anchor program if you don't know how to use the tools very well. Let me show another example. Is it in instruction?
But you know
Um,
but you know that writing constraints with native Rust is more work. So
it is,
do we
yeah.
guarantee that newbies can actually still do the same thing?
That's why I said it comes down to the experience of the developer, right? If the developer does not know about the tools, because now when I was writing this Pinocchio one, where is it? I think it's this one, yeah. In the initialize, I mapped out, because I know I mapped out all the things I want to do first. I mapped out that I want to check that the signer is a signer, that the signer
Mm-hmm.
is the account that you're creating is empty, the decimal
Mm-hmm.
is 6. I
Mm-hmm.
did all of this check because I know. So the same way knowing in this sense is required, is the same way knowing is required in Anchor. Because if you don't know in Anchor, so you will not know that you can have you can have a constraint that is asking for the mint, asking for the owner, asking that the key is this, and specifying custom errors for those particular parts, right? So it still comes down to the experience of a developer because you can still write inefficient programs very well. You can write a lot of inefficient programs in Anchor if you don't know. So it's basically the experience of a developer in that sense too. Mm, after that point, or do you differ? Is there what can you say to that? Do you beg to differ in that sense?
Yeah, it makes a lot of sense, and I think we need to like have this notion that everybody needs to like level up, because when you're dealing with constraints, for example, in Anchor, you get to write more code in Pinocchio and native Rust. So as you said, yes,
Yeah,
it boils down to the developer's knowledge. So you should be able to know how to do these things, and you should be able to map out what are the constraints, what are the params you need to feed in, and make sure you handle cases where those params are not found. So there's this thing where
yes,
I would always say, in if you're expecting a number, you should also handle cases where if that number is not given, if the number is not the number you're expecting, if the number is of different type, if it's
yes,
invalid, so like these are the things that are very important for people to know how to do. So yeah, I
yeah,
agree with you very like I agree with you. Like when you have to do all these things, you have to be very, very sure this is what I need to do, and then you need to map it out and do it properly.
yeah. And you can also do a zero copy in Anchor, but it is this one is like me like high level tier thing for a developer. So you can have an account, then specify that that account is zero copy. Then you see what I was doing in Pinocchio. But a new guy cannot do it. Like someone that is new to Anchor will not even want to. You're like, what the hell is this? You see, you can specify what you want on the account too in Anchor, zero copy. But someone that is new to Pinocchio, someone that is new to Anchor will not even want to come near this. But if you are a newbie in Pinocchio and you know Rust to some extent, you will need to do that as it. So what other question? Okay, what else you want to talk about? What else you want to talk about? Let's see. What else can we talk about on Anchor Pinocchio? Should we do Anchor Pinocchio or yeah? Nah, there are still a lot of things about Anchor that most people don't even go to. There's a specific tab dedicated to zero copy on Anchor in Anchor, and how you can do it. But it's too much work for a developer. It's too much work for a developer. E- yeah, yeah. So how about testing libraries? Testing libraries. What do you think? What's the state of testing libraries currently in Solana as a whole?
Yeah, we have a lot of good testing frameworks. We have Softpool, we have Light SVM, and I think even on the TS side, we have like good programs that can help you. Good DevX tools. So we're really like very good on that. Um, one thing that I think is also very important is like go and practice and learn all those things and know how to use it. Most of them offer advantages over others. For example, if
Yeah,
you're using Softpool, you know that you can spin up like your tests. You can make you can make some easy test process. Like when I used Softpool, I used it in the area of trying to spin up my instructions fast. Having the test UI, I really love that the test UI where you can actually just spin up the inputs. You can make the inputs, you can like get the results, and then you can also simulate whatever it's scenario, and then you can like where you have the information of like accounts from another chain, So I mean, I really love tools like that, like softball. Really love using softball. So tools DevX really like really good in on Solana. Yeah,
Okay.
pretty much.
Okay. I'll see. I think it is. It is. It has actually caught up a lot. It has developed a lot compared to last year. Last year it was still chaos. There was chaos everywhere last year concerning DevX student. But there was no stable thing. You cannot point to this is the standard, and there's still no standard way of doing it. Like compared to if you are in Ethereum, you can use Foundry, you can use Adapt, you can use all of they're like two, three major ones. But Solana is still now is leaning towards what's soft leaning towards soft mostly, but not everybody is still comfortable with it. That might take a while to mature to that extent where everybody feels okay, softful is the go-to. And would they actually be a go-to for dev for testing in Solana?
What would you say is the best scenario for testing on Solana? Like if like from experience or from what would you expect? What would you say is something that I can do with testing on Solana? Like tools.
Now, if you're writing Pinocchio, you will be forced to do unit testing. Unit testing you can do with Mollusk, you can do with Light SVM. I think you
Yeah.
can do with Softful. I've not used Softful with Pinocchio. I don't think can you? I've not done it before. So it depends on what level of testing you want to do. Like now, if you do unit testing, you want to do your integration tests before you now round everything up into a whole. So for me, if I'm doing unit testing, my go-to is Light SVM. I can use Mollusk, I can benchmark. Just depend. It determines. It comes down to how creative is the developer. As a dev, what do you want to? What are the things you want to do? If you're using Molus, you can create benches on top of that. So you can use different. You can benchmark with Molus, but with Light SVM, can you do benchmarks? So you can with Molus, you can create benches and see. Okay, if I use this implementation of this function, this is the CU that will become consumed. So I think Mollusk is more robust for unit testing, but I've not done a lot of Mollusk. I've just been using Light SVM for a long time, and yeah, it has done what I need to do, especially for time travel, for dumping an account. You can fetch an account from mainnet, fetch an account from devnet, and use the account details inside your Light SVM instance directly. But for things like it gets complex for things like uh let's say my ephemeral roll up, magic block and all those stuff. You cannot yeah, that's where Light SVM answer that no, that's that's not my goal. That's not what I was created for. Because as others, ephemeral roll up is a different environment entirely. So that way you want to push to integration tests, then start doing things on DevNet or but I think you can use magic block test with it's software, right?
Yeah, yeah, you can. Yeah, you can.
Yeah. So I think that would be where you can do soft routing. I don't think you can use light SVM with Magic Block for the ephemeral roll-up state and all because it's not aware of what's going on there. But I think that way soft shines. So when we're creating module, when we go to the light SVM, when we go to the Magic Block part, we have to move to integration test, move to implementation. So use DevNet, so use Magic Block DevNet, ephemeral roll-up and all. So we have to comment out our like SVM tests and start testing things on DevNet usually. Yeah, so that's basically what I would say is the state of integration testing for me. Yeah. So we have how many minutes have we? We are almost okay. We have like 1 hour
Yeah,
15 minutes more till this.
you've gone like 4 hours. I mean that's amazing. I
Yeah.
guess I can only do
Yeah.
like stuff like this when I'm coding. I don't really have anything to tell the camera. you know. So kudos to you this. I hope
Yeah.
everyone watching
Thank
could learn a thing or two about the session today. Yeah, I mean, I like one last thing to say before I go is 2026. I want to understand how things work deeper in like under the hood. So for Anchor, I would also like go deep into their macros. They have a lot of macros. So I have to go deep into their macros and look at how the macros work. Not really to contribute, but just to understand what happens under the hood, and also write more native Rust codes. And yeah, I have an interest with network engineering. Understanding how the
Network.
network works and transportation, data transportation packets, stuff like that, TCP, UDP, quick, and the rest of them. So
Yeah, I think
2026,
2026 will reward. It will be more rewarding for devs that want to go into those deep level stuff. If you're on the surface, there are people on the surface. You have to 2026. You want to go deeper, and that's crazy amount of work. It's crazy.
yeah,
You have to do things
yeah.
that yeah,
So
go
yeah, let's look at what one thing is for each breakpoint, because like breakpoint is next week. For each breakpoint, there's this standard set, and then there is a new wave of things to anticipate in the coming year. So
okay.
really excited to see what the guys have to tell us during the this coming breakpoint, and then what standards are we going to pursue, you know, coming year. So I think we would have things like Alpen Glow talked about, and then we can now look into how these things work under the hood. Become better devs. You get. So yeah,
Yeah.
that's what I think would be nice for 2026.
Let's see. Let's wait and see. Let's wait and see. But while we're waiting, we're doing deep level research and doing. So thanks for spending the time. For the time to come and chat about stuff. So
Yeah,
we are releasing you now. If you want to stay, you can still stay.
yeah,
So
gotta
we'll
go.
be
I
going
have
into.
to. You have to get some work
Thank
done.
you.
I'll see you guys later. Yeah, have a good day.
Yeah, bro. Thanks a lot for hanging out. Yeah. So let's see. Let's see. What should we get back to now? Let's do. Should we continue? Should we continue writing our Pinocchio program? I think. Yeah. And yeah. And yeah. Yeah. I can do this. Okay. So we are porting for people that are just joining. We are porting an alpha program to Pinocchio, and we'll be talking about everything in between. Yeah, and I've been goofing around too, quite a lot. So let's see. Should we proceed? Yeah, let's proceed. I would want us to go into. Okay, that would be talk for some other time. Yeah, yeah. How you doing, bro? Yeah. So I would like us to go into. There might be maybe next week. I want to do or 2 weeks time. It's 3 days of DeFi. So 3 days of DeFi would be everything DeFi. You already know Anchor. You might know Pinocchio. So once you use that experience to build AMMs, staking dApps, staking programs, GLMM, all those complex DeFi things. We would have some speakers talk about them. So it will be 3 days. You can't cover everything in one day. So 3 days might be 3 hours per session or 2 hours per session. That we'll leave that for next week. I would announce on the timeline though. So you guys will not just be on the surface or at the backstage and be looking at, oh, that's awesome. How would I get to know about that? So you can get to know about that. Yeah, you see people write code real time explaining. It'll be like a workshop session. Yeah, next week. So let's continue. Let's continue. The next one we want to create now is the instruction for. We've done the initialize and we've tested it. Test for the initialize is this one. Uh, Create global state function. So I would actually want to. You see what I'm talking about in a minute. Like I said, every test is an island in Pinocchio in Rust. This test is an island. If I have another test, I cannot communicate. This everything I did there has been sent to the blockchain and it will reset basically. So the next test is not aware that I ran this previous test. I will need to rerun the create before I do the create user. But there's a way to abstract that, and we'll do that soon. But let's get to writing. So the next instruction after initialize is create a streamer. So it will be the same thing, not the same thing actually, but similar. Let me bump up the music a bit so I can hear something. It's so loud. Like this. Okay. So so let's call this one process create account. So we'll have a create streamer. So process create stream create stream create streamer is taking accounts, it's an array of account info and taking data, the data slice of whatever. And we're not getting any data. We're not using any data here. We don't need any data. Let's check the anchor program. So please type in a streamer. Let's get to creating a streamer program switch from source instruction. Instruction, then create streamer, reload this. So create streamer. Yeah, so the create streamer, we don't have any instruction. We're not passing any instruction here. So let's see, and we are not passing any instruction in the librs also, right? It is source, then librs. So if we've done the initialize, with the initialize we are passing this param instruction, but in the handle create stream, we're not passing any instruction, just the bump. So yeah, we don't need any instruction handlers there. We don't need any instruction data there rather. So we have this process create stream instruction. So program result is from Pinocchio, program result, account info is from Pinocchio, account info. Yeah, I save this program results, program results. Okay, 1 minute. Yes, program. Okay. My bad. I was supposed to do an okay here. Okay. Yeah. So let me go to librs. Inside the librs, we have this initialize instruction. The next one is when the case is switched instruction, create streamer. I want to call this process create streamer. Then we'll pass in the account, then we'll pass in the data. Then we do this, then we do this. Cannot find process create streamer in this instruction. Process create streamer. Yeah. There you go. Yep. So now let's get into create streamer. Let's see. In our anchor program, what we did was, so these are the accounts we need: signer, broadcaster, streamer state, token mint, streamer ETA, global state. I'll just copy all of this. 1 minute. Let me copy all of these accounts first. Yeah, so I will. This is even more tiring than just writing it. Bro, 1 minute. Signer, then broadcaster. I will explain why we're using a signer and broadcaster in a minute. Broadcaster, then streamer state. Token time. Then token mint, then streamer ETA, then global state. Almost there, almost there. System program. Yes, I can do this. I'm just digging into that. It's crazy. This one also remove this one. And we are good to go. So I can do accounts. No, not don't do that to me. Accounts, other accounts. Then there's an else there, right? So if I initialize equals account or else return this error mod. Yeah, so these are all the accounts we need for this instruction, right? The signer, the broadcaster, the streamer state, the token mint, the streamer ETA, the global state, the system program, token program, and the token program. So now let's get on to our conditions. So we want to ensure that signer is a signer. So we want to assert that signer is a signer. Then we want to also assert that broadcaster is a signer once because this is the broadcaster is paying the transaction fee in this instance. Then assert that streamer state want to make sure streamer state PDA is empty. Because we want to create the account. Should it be empty? Create streamer. Let's do it it's a one-off thing. Let's make it a one-off thing. It should be empty when we're creating the streamer. Let's check. Let's make it exactly a one-to-one copy. So this one is an init if needed. Here is broadcaster, space is this. I only want to create a streamer once. So what am I doing? Yeah, create streamer should be, let's make it a one-off thing. I want to assert streamer state is empty. So I want to assert also that streamer state generated or derived off chain, because we're creating it the same as the one completed on chain. So the streamer state we are sending from the client must be same thing with the one that we derive on chain. So we are computing off chain and not deriving on chain. Else there will be, so that what we're doing there is just it's native needed is okay. What we're doing there is just making sure the PDA are sending here, the seed that was used to create the PDA off chain is the same one that we use when we're creating the account on chain. Right? So what other checks can we do? We need to assert token mint the same as one stored in PDA in global state. We want to be sure that the token mint that you are passing is the same one that is stored in global state. We also want to assert that what else? Token mint is of 6 decimals. We have done this previously, so we don't need it again. Since we've asserted that it is of 6 decimal previously, and we've saved it, so this assertion is redundant in that sense. So we've touched token mint, we've touched the streamer state. So we used to touch the streamer ATA. Assert streamer ATA is of type. So the type of the token mint, we want to make sure that the token, the ATA, the mint of the ATA, the same mint that we are expecting. Yeah. Store token mint, store streamer ATA. So I want to create streamer ATA also, right? So I want to create streamer ATA. Oh, we're not creating streamer ATA. Yeah. We want to use streamer ATA. That means streamer ATA needs to be created in the client. Because in streamer ATA, yeah, streamer ATA is native needed. Yeah, because so we need to ensure that the authority of streamer ATA is streamer state. Assets, that's authority, streamer ATA authority, ATA authority is what streamer state. This I said that streamer ATA authority is streamer state. We also need to check that the streamer ATA exists because we want to ensure that they have created it off chain, right? Sorry, asset streamer ATA is not empty. Is not empty. That's all the checks we are doing. And after that, we create streamer states. Then we write streamer states. Yeah, so this is, I think this is comprehensive enough. This is exhaustive, I think. So what are the steps we did here? We just created it simple and straightforward. This anchor makes it simple. So let's get to it. So let's start with these are assets that signer is the signer, asset that broker is the signer. So let's do asset signer is signer. That's just an accounting flow. That's signer should be a signer. And same thing goes for the broadcaster. We need to assert that the broadcaster is also a signer. Assert broadcaster is signer. So we do broadcaster should be a signer. Simple, straightforward stuff. We need to assert that streamer state is empty. The streamer state, we need to assert streamer state streamer state dot is empty. Is empty. Data is empty. Yep. Just as the data is empty, else provided streamer state already exists. Already exists. State. And what did I check? Check that streamer state is derived from the completed one. So let's derive. Let's derive PDA on bomb equals pub key find program address. So we need to get the seed. Seed here is what type? Seed here is UH. So we just need to have a borrow of so we have B, I think it's user, and the key of the user. Let me confirm. For the streamer state state the seeds are the user and the signer. Then signer dot key dot asref, the asref on it. Yeah, that's all. Then program ID is the thread ID. So this is derived PDA, user and the signer. We need to assert that that is correct. So we need to assert to make sure assert that derived PDA dot key pub key equals pub key. We have a pub key equals, so we can use that. Pub key equals to assert that derived PDA is a slice. Let's borrow that. Let me borrow that reference. Derived PDA and streamer state dot key. Yes, they must be equal, or else the derived streamer state is of wrong keys. That's the wrong keys for derived streamer state. Can do that. So now let's do one more check. What else? Assert that token means is the same as the one stored. So first we need to get the global state as an account, right? So let's get global state as an account. Global state account. Global states redundant, right? Is what type of account is it? We have a global state, so we use bytemark. Bytemark tripod read and aligned. Then what we are reading is we are reading streamer state. I'm reading it as streamer. Yes, that's streamer. Oh, sorry. We're reading it as global state first. This is global state, not streamer state. So global state is, so this one should be global state. Global state dot 2 bytes. 2 bytes. Should be dot data. Then data. Let's dot as global state. Let me see what the problem is here. Yeah, so there should be a 2 bytes on it now. 2 bytes. So there should be an as. I mean, let's check how we did the initialize token account info. Data is, so is there an account info? No. With streamer should have, oh, I see. 1 minute. That's what the problem is. It's an account info, but this is not. We want to access that token means the same one as stored in the global state. So we want to read global state as an account with an account info. So is there a 2 byte on account info? Let me see. You can borrow data coming up. Executable owner clone trying to plug into borrow the pointer data is empty. Check borrow data on check. I want check thing. Should we try borrow data? Try borrow data. Yep, it should be it. So almost so I need to borrow that one. Okay. Yeah. So global states, try borrow data. Yeah, that should work. Yeah, that should work. Got an app. There should be an error there. If there's an error there, it should fail. It's a panic anyways. So let's global states. Yeah. So now we can check assets, assets, pub key equals global states dot supported token mint. Yeah, it's the same one as token mint. Borrow that. Borrowed already. Dot key. I think else say you provided wrong token mint. Yeah, expected borrow. My bad. So now you asserted that this is working. So let's assert one more time that streamer ATA is not empty. So assert streamer ATA data is empty. So need to assert that data is not empty. Let's say streamer ATA does not exist. Cool. So now we need to assert that streamer ATA is of type token mint. We need to convert that account into a token account. Let's streamer ATA state because we have a mint. It's a mint, right? Streamer ATA. No, streamer ATA is not a mint. Streamer ATA token mint. Streamer ATA is of type. So it's a token account. Yeah, token account. And from account info, yep. Sorry. From account info, yes, I will pass in the account info of the streamer ATA. Streamer ATA. Yeah, it's good. I think. Did I just unwrap that? Yep. So to make sure assets streamer ATA states streamer ATA states dot mint. Yep. Is the token mint. So this is pub key equals blah, 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 blah. So what is that pub key? So we need to get it from token mint. Excuse me. And streamer ATA. I think I should borrow this. So if it's not equal, say you provide wrong, you provided, just say wrong, wrong token account for streamer. Excuse me. So we have done this assertion such streamer is of type token mint. So the mint of this streamer ETA state must be the same token mint. Then one more assertion, we need to assert that the streamer ETA authority is the streamer state. So we need to assert the pub key equals first pub key is streamer ETA state dot authority, an authority dot close authority, double authority. I think it should be owner streamer ETA. The owner is the owner. The owner should be the owner should be a pub key. I'm sorry. The owner of this account will be the token program of streamer. Let me check. Let me use an example. It's a DevNet wallet, right? Yes. Got it, bro. Got it. Let me copy this wallet address. Let me go to scan. So scan. I want to see is the owner a token ID? Is the owner a program ID or is the owner a pub key? So let's see. I'm missing. So I'm trying to see, do I have an owner or do I have an authority on that program ID? What I'm trying to look for. So this account. Yeah. Okay, that's not a token account. So that's not a token account. Let me look for token account. Token account. Well, I can get token account from portfolio accounts. Yeah, token account. So the owner. Okay, so the owner is not the program ID. The owner is the owner. The owner is the owner. Yeah, the owner is this guy. All right, so I can use the owner. So the owner must be equal to. What am I looking for? Streamer state. Yes, streamer state dot key. Else, let's shout and say streamer state must be authority. Yep. So now that this is done, we need to create streamer states. To create the accounts, use create account from latest VM. No, sorry, Pinocchio. It's not associated token account. I'm creating an account. This is a regular account. Pinocchio system instruction, create account. Yes. So we do from who's paying for this. The broadcaster is paying for this. Broadcaster is paying for this. Lamport is, we need to know the Lamport. So we need to get, after this token program, we need to get also rent var, rent system variable, and initialize. We already did that in initialize. Let me copy rent state equals this, minimum balance equals this, initial bump equals this, seat, and just copy the whole thing here. Yep. In the crates. Yep. So rent this one. You can have rent from make it is rent. So now we are looking for streamer state here. Streamer length as a length. The bump is the bump. Initial so seed is from Pinocchio seed. Yep. So now the seed here is user, and after user is what? User and the signer. Then before the bump, we receive from signer dot key and we are good to go. So signer is still from Pinocchio signer. I already explained what the signer type and SIP type is previously, as at the beginning of the tutorial, the stream tutorial, right tutorial. So now port is the minimum balance. Then owner, this case is a create ID. Then space is the streamer length, because we already have a streamer here in the state. This is what the streamer is. A streamer is a pub key, and a bump. So the user wallet is pub key, token account is pub key, bump is pub key. So the length of this is 32 plus 32, that's 64 plus 1, that's 65. So the length should be 65. Yes, so length is 65. So that length, what to pay for the length is 65. So streamer length. Then two, the account that we're creating is the streamer state dot invoke signed. So the signer is signers, I think. And we have this borrow. This should also be a borrow. This is 5 found this size as U64. The signer here expected should be a signer like this. Yep. So after we've created the account successfully, then we can write to the account. How do we write to the account? We use ByteMock, right? ByteMock, yeah. Let's get the account info. Let's account data is streamer state. We'll have some issues here because of scoping and borrowing and out of range, but we'll fix it. Streamer state dot try borrow mute data. I want to borrow the data mutably, not the lampers. Try borrow mute data. Now let's data borrowed, whatever data borrowed. Let's call it streamer data. Streamer data. Now so streamer data is ByteMock. So ByteMock. So from bytes mutable. So we now do the type of account that we're borrowing mutable is streamer. Borrow that streamer account. Then the data is account data. Yeah. So I save this, yeah, save this. What's the problem here? Cannot mutate immutable variable account data. My bad. It's anywhere I put the mix. Yes. So I can just put account data. It needs it. Then now I can say streamer data update. I think this music is loud. Is it loud? Is it loud? It is loud. Now it's even louder. I think it should be. Yeah, so I can now say streamer data dot user token account is user token account is streamer ATA dot key. Yeah, and I can say streamer data dot user wallet is signer. Yeah, signer dot key. Then I also want to save the bump. Streamer data dot bump equals to, I think is this initial bump, no, bump, just the bump. It's the bump and every byte 281 expected this. I need to dereference that, then dereference this. So if I save that, dereference this, save that, save this should be good to go. Good to go, but we might have some issues actually. No problem. Let's just do cargo build SDF. No errors, only some warnings. Full with warnings. So let's try writing the test for this, right? So there's nothing interesting, there's no testing it. Might have some errors. We should. If we do something right, we should. All right, so let me get to the test part I was talking about. The problem would be here that we have a create global state, but yeah, when I'm writing the next test, writing another test here, and the test is for fn, what's the word, create streamer. Create streamer is returning a result of okay and error. Yeah, return okay. What's this? But okay, right. So the problem would be this create streamer. Now there won't be a global state because we just created a global state here. That's one. Is removed from the whole is removed from this. Is not a persistent SVM, right? It's not a persistent virtual machine. Once you've created that, that's gone. Like it's not aware of that. So we need to create it in the same instruction again. So how do we do that? Let's have this function separate. Let's call it pub fn handle create global state. It's not returning anything. It's just unreturn global state. So let's move all of. Let's see. What's the best way to do that? I want to see how I do it in this example. This one. So example. So it's the yeah, I think this one. So yeah, what I did was I added create fundraiser function outside, so it handles all of the repetitive tasks. So I can create the fundraiser here. Yes, 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 yes. Twice it, twice it, twice it, twice it. Contribute. Create fundraiser. So inside the create fundraiser, that's where I have all of this stuff. Then inside the test, FN contribute specify the inside the test itself. Inside the test itself, I just called create fundraiser, and the test is not returning anything. So yeah, let me do let me do that. Yeah. So the test might not return anything. That's totally up to the test. So let's call undo create global state. So all of this, so undo create global state will take in a meet SVM, taking a mutable SVM and a reusable state. Yep, taking these guys. So taking these guys. Meet SVM is of type light SVM, and reusable state is of type reusable state. Yeah, that's it. Then it returns a result or error, whichever the case is. Returns. Yep, so I can move all of these. Move all of these. Move all of this into this. So yeah, I just need to call undo create global state. Then I pass in SVM. Now pass in reusable state also. Then the problem, I've set treasury data, so I can call here reusable state dot treasury data. Is there a treasury? What's treasury ATA in this place? Treasury ATA, where are you? Reusable state dot treasury. Yeah, I'm returning an okay. So yeah, reusable state dot treasury. Treasury same as yeah. What the these are moved variable reusable state value moved. Yes. Should I take test the assertion inside SVM? Yeah, I know. So I can borrow it mutably here. If I borrow it mutably here, no, that should not be a problem. Let me just move. Let me move all of these assertions inside that place. Let me move all of the type here. X. Let me move all of this here. Yeah. So let me see. Let me see if I run cargo build SDF and cargo run I have no capture. We still have no problems. Yeah, blah 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 blah. Cargo test, not cargo run. Good. So now let's put this one here. We also need to have this and this. So we need to handle these two first. Let's see if the two tests will pass. So we should have two passing tests. Zero passed. Okay, yeah. Two passed, zero failed. And yeah. So let's now continue. We've already handled that. So let's create another function outside here that does handle create streamer. Taking in is taking in wait, that might be a problem. So mute SVN because you should take in a mutable reference to create fundraiser. Not we should take in a mutable reference. So our create fundraiser should take in a mutable reference here. So yeah, that was the problem. So that will still be a problem. So this should take in mutable reference and this should take in a borrow. Yeah, maybe I don't know. What's the error here? Where's the error? What's the problem here? Use okay, this one. Then this under global state should take in a mutable reference. So this should be a mutable reference, right? 1 minute, 1 minute, 1 minute. So yeah, should be a mutable reference, not the direct, not owning it. Be a mutable reference. Yeah. Uh, should be this. Enable state admin, can't move out of admin. Uh, 1 minute, let me see. How did I solve this then? I think that's gone. So now I can just put borrow mutable here. Yeah, so I borrowed mutable here also. It's yeah, let me run that again. Yeah, all tests passing. We're good to go. Now let's create the one for this guy. So it should be similar. SVM is made this, and this should be that. Alright. So now let's go and create the instruction on that. So for our create streamer, what we're looking for what to use is still here. But here are the accounts we need. Here are the accounts that we need for that instruction. State mod rs, test mod rs. Then, like I said, we start by writing the end. So the end justify the means. So we want an account instruction that looks like this. Instruction. So we want something like this. So this should be called create create instruction. The instruction, then we need signer. It's called signer, right? Yeah, same thing here. Signer. Then we need a broadcaster. Should also be a signer. So that do accounts meta new. Then put the broadcaster here. Dot pub key cricket noise, and that's also true. Signer. Yeah. So now let's get all of this. The streamer state first. We also need the streamer state, which is not a signer. We need global state. We need global state also. Let's streamer state. Streamer state dot zero, because that's a PDA. It's not a signer, so that's false. I'm going to create streamer state also. After streamer state, you need token mint, so mint should come before after streamer state, right? After streamer state, you need the mint, and after streamer state, after the mint, we need the streamer ATA. So this should be, let's call this streamer ATA. Streamer ATA, move this after the mint, right? After the mint. Then after that, we have the global state. Then after that, system program, token program comes before ATA program in this sense. System program, the system program, then token program, then ATA, then rent ID. So yeah, here are all the accounts that we need. So now let's start looking for them. Let's pair equals reusable states dot admin. Let's just use admin. Admin dot key. Is it dot key or dot pub key? I think it's dot pub key. Yeah, pub key. Let the admin. Okay, that should be broadcast. That should be admin. Broadcaster. So let's now see. Let's pair equals key pair. New, create a, sorry, new, and we also airdrop that key pair some lamp ports. So let's airdrop svm.airdrop airdrop some lamp ports to that pair. So now let's call this pair. I think that's cool. Then streamer states. We have to create streamer states. Let's get that from. We already have a create find program address. So this one. We want to. I don't think we might be able to finish this today though. Let's try to get the test working. So pub key find is called user. Is already a ref already. Then after the user, we need the signer. So pair dot pub key dot as ref. So these are the three seeds for the streamer states. Three keys for the streamer states. Broadcaster of pub key. Meta pub key does not. Meta pub key exists but for struct pub key, but it's still found not satisfied. Pub key. I think it's because of this broadcaster. broadcaster is let me remove this, and that should work. So the mint is, let's token mint is readable state of token mint, right? Readable state dot token mint dot mint dot mint. I call it mint, so I am calling token mint here. Mint. So streamer ATA. Now we need to create a streamer ATA. How did we do that? We created an ATA somewhere here. Yep. Yep. We have an ATA here. 1 minute. So the owner of the token must be the one creating. Sorry, my bad. New, the payer, whoever is paying for it. Then the mint of the token is mint. Then the owner. So set the owner of the account. So the owner here is payer also. Yeah. We are creating an ATA. Yeah. Let me mint. Then to mint some tokens into it. We'll say, let's see, mint. Is there a mint transaction? Let me mint transaction here. All right. So let's leave that. Treasury token account. We also need to make sure that owner is allow owner of course, right? Then another thing. Okay, I think this one does that automatically. Create a token account. There mint owner new ATA. We need to make sure the owner is of course. I think that owner set the owner of the account. I think this one does not check if it's on cover, of course, right? So no problem. Then this is called streamer ATA. Oh, streamer ATA. Streamer ATA. So who's the owner of the streamer ATA in this place? The owner is not the payer. The owner is streamer state. Yeah, the owner is streamer state. Dot zero. Yeah, so that's the owner of the account. Because it's an ATA for the streamer. So global state, we have global state already. Let global state equals reusable state plus global state 0. I just leave the 0 away. I'm doing that already. Then system program. Just copy system program and all from this one. Token program, system program. Then rent is rent. I already have that one. Token program, system program, ATA ID. ATA ID, Agita token account. ATA ID is what? Yeah, ATA ID. Usable state dot ATA ID program ID. Just copy this one too. And yeah, so there's no data, so we can use. Oh, sorry, there's a data. We need to pass in the discriminator first. Let's ix data equals an array. Sorry, an array. Then we have to get this as a vector first. Vec of Streamer. Switched switched instruction. Hmm. This instruction. Yes. Then create. Think that works. Yes. As U8. That's the only thing there. Dot concat. So that's the only thing we need for that instruction handler. So yep, we are good to go on that one. What else? What else? What else? What else? Because there's no instruction data, I just passing just the discriminator. The first schema is one. Then the next thing is sign the transaction, and we should be greeted with some errors to be successfully pull this off and the creation of this problem. So I cannot move out of. Oh yeah. But the money is already moving borrow. Nah. Not my problem. Search to get the message, send transaction, copy this. Let's see if this should work. So now you create instruction, then who is paying for this instruction? The broadcaster. Broadcaster is paying for the instruction. The broadcaster is signing the instruction. In our next instruction, we can call undo create streamer. So in this next one, okay, let me start off from cannot mutate mutable variable SVM. Undo create cannot mutate mutable variable SVM. Okay, I think needs to borrow this SVM. Let me put SVM here. But this one is owning it. If you own it here, then I cannot. Oh, that worked. I did it work. No errors. Okay. Let's run this. Let's see. There should be one error. Yeah, give me the errors. Wow, no errors. I'm used. Let me see. Did we call the right instruction? Uh, create global state, create streamer. Oh yeah, of course we did it. Handle create streamer. I was like, why would there be no errors? So after, why am I calling create global state again? Create streamer. That's what I want. Yeah, so now let's get to the errors. Yeah, it is. I'm using. Sorry for that. I'm using StreamYard. StreamYard is the platform. StreamYard. So the answer to this question, streaming platform, yeah, StreamYard is what I'm using. Yeah, thanks, bro. Let me see. Let me just drop it in the chat. In the chat. In the chat. Can I do that? It's called StreamYard. If I can get a link to it. StreamYard. Oh, sorry, not StreamYard. I'm using Restream. Sorry, my bad. I'm using Restream, not StreamYard. I'm using Restream. That's the link. Let me get Restream, not stream yet. Let me take this down. Hi. I'm using Restream. Restream is a lot of features that StreamYard does not. I think I don't know. I migrated from StreamYard. I was using StreamYard initially. That was the first two streams. Then after then, yeah, StreamYard is expensive. Yeah, StreamYard is expensive. Stream is cheaper than StreamYard. Mm, but it's cool. Let me see if I can get the link. Restream, Restream, Restream. Yes, app.restream.io. So we just get this one. This one, yeah. 1 minute. Let me answer the chat. Quick. Yeah, that's one I'm using. This one, yeah. This one I'm using app direction, but I just check the chat. Mm, so let's see. Let's see. Now let's get to the errors, the beautiful errors. And the crest streamer, and the crest streamer. Now, greet me with errors. Yes, finally, one error. So that's the error now. Yeah. Which one? So which one first? Yeah, I want to get the logs, so I need to do logs. I need to get the logs, so know what failed initially. So in the handle create streamer, I also want to log, I want to get the TX logs, and that's from CX logs. Yeah. Yes. So wait, 1 minute. Let me remove this iPhone. Let me remove this one where the error is coming from. Let me remove these logs from here. This one. Remove this one. Yeah. I think so. I can see what's going on actually. Yeah, not enough signers. So we are missing some signers. That's good. So let's see. Let's see. I'm sure I missed something. For the crates, then create streamer accounts. You have one, two, three. Let me just copy this again. So we're supposed to have one, two. So signer, broadcaster, streamer state, token mint, streamer ATA, global states, system program, token program, ATA program, and rent silver. So something's wrong somewhere. Accounts. Oh, my bad. Did I did? What's the error here? Okay, this one. So what's the problem? True. The sign on the broadcaster. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Token program 8, 9, 10. So there must be something somewhere in it. Um, Not enough keys. Did I have anything happen to have not enough keys? Not enough signers. Oh yeah, my bad. Not enough signers means I should have a signer here also because this is signing the transaction. Some signers. Message is payer is this guy. So but transaction from keeper signing the message. So this one is payer. Should payer even be the right word here? Let me do this guy. Okay. Should be where the keys are. So broadcaster and payer. So that should fix it. So what's the error this time? Yes, now I have some logs. Oh, he passed. No, that's crazy. Should it pass? That's actually crazy. How am I doing this? How do I have two instructions passing? That's cool. Invoke. So first one he did was this one program account. Then did this pass or did this actually fail? So init consumed. So it should not be init. This one should be create. So tx logs handle create stream. So in the log should say create. Let me move the logs now since it's passing. Yeah, I needed to put the CUs of this one also. CUs consumed. After we got the log, I will not even sure we're going to get the logs. It's great, bro. So now I can let me move the logs for now. Then run see what CUs consumed again. Yeah, so 6K CUs was what was used to create the streamer account. Why? Because there are a lot of things that we did inside the streamer account. So that's like twice. That's it. How many things do we do inside the streamer account? Is it not relatively the same? Oh. Let me see. Let me read the logs carefully. Yes, this one consumes 310, this one consumes 310, then the next one consumes 6,080. Let's check what went wrong. I'm surprised that I don't have to modify anything in the program to make it work. I feel somehow, I don't know how I feel. It feels off. The program worked just like that. Alright, so not the states in the instruction. 5 hours in already. Wow, cool. in the instruction, in the create. So what we did was we did a lot of assertions. We derived PDA. We assert. Okay, we did a lot of assertions. Right, that was basically why. A lot of assertions. A lot. Yeah, we're good. We're good. We're good. So we were able to complete the create, write the test for that, and we wrote the test for the initialize. I wrote the test for create also. I'm just going to push this to GitHub real quick and take a break and celebrate our 5 hours of Solana. We'll git add, then git commit. It's still crazy that this thing worked. Sorry, that's no, it's commit like sit is wrote and tested create streamer. You guys can go over it and see anything that you would like to modify. You can make PR so it's push. And if you like to write the other instructions also, you have the reference and you have where the destination is. So all of that is in the chat. This chat, this is the link to the Pinocchio version. Pinocchio version of that is where exactly are you, brother? I think it is one. Pinocchio, a minute. Let me find it. Should be. I have the link here. Why am I looking for it again? So can I copy this? Uh, cannot copy. I can only show. Let me go to the Twitter. Let me go to Twitter and click on it. I don't even have access to previous chats. Let me see. Let me see. Okay. All right. Let me get the link to that one more time. This guy on the main. I can click on this one, and I should have it loading right here. Well, that should be right here. I hope this one works this time. I also have to change this to github.com. And it's probably not going to work. So let me just change it to github.com. Yeah, this is it. I should probably put a good review. Anybody can make a PR for the good review, please. I'll be most appreciated. And we have 2 minutes ago the comment rose and tested Chris streamer. Fit. I wrote first. Bro, crazy. Alright guys, thanks for your time. This has been the anchor found. Wait, 1 minute. I need to put this out. This should be muscle memory by now. I need to have this up before I start thanking you guys. Please sharing screen. I need to add presentation. I have this guy. Yeah, thanks a lot, guys. This has been the Anchor founder. And wait. I just show you a bigger one. Sorry. Yeah, I'll show you some preferably. Let me switch with this. Take this down. Put this back up. This should be deleted. Sorry. Remove this and put it back. Yeah. Thanks a lot, guys. This has been the Anchor founder, and catch you on the next episode. Thanks for staying. 5 hours. Peace.